the next next session. I mean the topic. So let us quickly understand where are you exactly. So what are the phases you have completed yesterday? Please confirm.
De- Define phase, sir.
Define
Define
phase.
define phase you have completed, right? Which means now all of you are very clear about the define phase. Is my understanding correct?
Yes.
Yes, sir.
So you should be able to develop a project charter in an impressive manner, and then you should be able to get it approved by the project sponsor. Whomsoever is the person who has the authority to approve your project, who can provide you the required resources to execute the project, and he is the project sponsor. And you should provide him enough information. You should give him enough confidence that you and your team is capable of fixing the problem. Yes or no? And that is why you prepare the project charter. Can one of you tell me what are the key elements a project charter should contain? And all of you feel free to turn on your camera and come on video. We'll have some interaction for 10 minutes and then only I'm going to teach you further. So what are the key elements of a project charter?
A project charter has 6 elements basically.
Great. Great.
First one, maybe we can say business case, then problem statement or opportunity statement, then goal statement,
Goal,
and
timeline, and then team members.
timeline and team members.
Team scope,
defined.
timeline, and team structure.
Very good. Very good. So that means you have developed a good understanding about the defined phase and the project charter. And now if we take one out of the six, let's say business case, what is expected to be communicated while drafting a business case?
Basically, in the business case, we have to demonstrate or we have to write what will be the benefit in terms of financial figures, monetary,
Very good.
and the focus point will be on the financial figures in business case.
How much we are saving or any
Great.
benefit for the organization.
That means you mean to say you need to focus only on the financial benefit while writing the business case?
Yes.
Suppose if you are the project sponsor, suppose you have elevated yourself to the level that you could approve projects. Would you like to look at only financial benefit, or is there anything else you would like to
No, we would
understand?
like to see the financial benefits as well as the company reputation. If at all from any project we are getting company enhancement, company reputation enhancement, then we will go for that project also.
So I'll just add you certain things here. In addition to the financial benefit, which are short-term gains, you can also talk about the long-term gains. You can also talk about the long-term gains. In general, you can call it as non-financial benefit, right? Which means in the longer run, that can get you more financial benefit. That is the point, right? Anyway, ultimately, everything is a financial benefit. But there are two types of benefits. One is short-term. Short-term means within the same financial year, you will get it. Long-term means maybe afterwards. It will take some time and then you will start seeing some financial benefit. Another point you need to include in your business case is that alignment of the KPI. Your boss will be reporting to your super boss. Yes or no? He might be reporting to above him. There will be someone, and then your boss will be responsible for certain KPIs. Can you find out one or two KPIs which your project can greatly improve? Do you get my point? If I do this project, the customer retention rate will also improve. And if you notice that your boss is responsible for the customer retention in your company, then you can talk about that also. This is called strategic alignment of the projects. So always, if the sponsor once understands, this project is supported, then my KPI will also improve. Then he will certainly be motivated enough to support your project. Yes or no? So keep 3 points in mind: financial benefit, non-financial benefit, and the third one,
KPIs.
alignment of KPI. What is the KPI? Your project KPI is one thing. and your boss, he will be working on certain KPI. How these two KPIs are, connected, and you can add a line, and making this project successful can greatly, enhance the customer retention rate. Right now, our customer retention rate is also somewhere around 40%, 30%, and this can be elevated to above 70%. So he will do you understand, all of you? Ultimately, you want your sponsor to approve your project charter. It is only after the approval of the project charter your project comes to life, right? So business case, and then while writing the problem statement, you should definitely talk about the pain metric. The pain metric, the pain being experienced by the customer, maybe external or internal. That pain metric should be part of your problem statement, right? And also if the pain metric related to the customer, you should be able to carefully, connect it to a technical metric. I mean, say for example, if there are, let's say, if there are quality issues happening, the specific quality issue leads to customer dissatisfaction. Why there is a quality issue? The product is not meeting some of the specification, maybe the dimensional requirement, or maybe the surface finish requirement, or the items are not produced as per the, specifications. So the CTQ is one thing, but internally, what is bothering the company is the rejection rate. Yes or no?
Yes.
The rejection rate and quality issue, are they related? Are they related or not?
Yes.
Yes, sir. Related, sir.
Customer gets dissatisfied by receiving a poor quality product, or by receiving products with some defects. It is because of the defects you have a higher rejection rate internally. Now this rejection rate is an internal metric which is, bothering your business. But poor quality product received by the customer actually is bothering your, end user
Sir.
or the customer. So the in line with the CTQ, you need to identify a metric known as CTB, which is known as critical to business. If you improve on the CTB, automatically you will be able to improve the CTQ also. Yes or no? If I reduce the rejection rate, automatically good quality products only will reach my customer.
Yes, sir.
So in this manner, you should align your CTQ as well as CTB. And once this alignment is understood, either you improve on the CTQ or you improve on the CTB, however, the problem will get solved. Only after this understanding, you can work on projects focusing on reducing the rejection rate. Right? You focus on reducing the rejection rate. In return, it will enhance your customer satisfaction. So the pain metric should be taken appropriately. And you should always, give a proper, some description about the problem. Just like, you explaining your issues whenever, you go to hospital or meet a doctor regarding a health issue. Would you like to communicate all your problems in a proper manner?
Yes.
Yeah, because the doctor has to understand, then only he can, give you a better suggestion. So the same manner, now while writing the problem statement, you should be able to effectively communicate the pain. What is actually leading to customer dissatisfaction? What is the metric you are trying to improve? And how long the problem is being experienced in a company? Is it just a 1 day problem, 2 day problem, or is it a problem for the last 3 months, or is it a problem for the last 1 year? Adding this information can greatly help. If you are talking about the pain, you are experiencing the stomach pain, should you add the number of days you are experiencing the problem? Is it just
Yes.
a sudden stomach pain, or is it a stomach pain for the last complete week, or is it a stomach pain for your, complete month? You should communicate, yes, sir. So
Yes.
your problem description should necessarily talk about the duration of the problem that exists. All right, and then who is actually, where exactly the issue is happening, which department, particularly first of all, which factory, which location, which department, which product, what exactly is the defect. This information, in specific terms should appear in your problem statement. Because the generic problem statement, cannot help. You have to know, drill down and make it to the point. So where is the problem happening and who is getting affected and how long the problem is, happening. All these things should be part of your problem statement, right? And correctly talking about the current level of the problem. When you're talking about rejection rate, what is the current rejection rate? That you must show in your project charter. Yes or no?
Yes.
Yes.
Yeah. And if possible, also please add what will happen if the problem is left unattended. If the
Impact.
problem is left
Impact.
unattended, then the existing contract will also get cancelled. The customer, is already experiencing the problem for the last 3 months. If we don't fix this right now, then this might lead to the contract cancellation, and so the customer retention rate will also get affected. This you must add it in the problem statement. Clear, all of you? One is goal statement, the other one is flawless statement, and then
Goal.
yes, business case, problem statement, and then the goal statement. Your goal should be SMART, isn't it? What do we mean by SMART? S stands for
Specific.
specific, measurable, achievable, relevant,
Achievable,
time
relevant.
bounded. Specificness, yes, if you talk in terms of the specific location where the problem is happening, specific product, specific type of defect, specific type of non-conformance you are trying to fix. If you do, or if you mention all of that, automatically your problem will be specific. And tell me, if you're talking about rejection rate, will you be able to measure rejection rate accurately? Is it possible? Possible or not?
Yes, sir. Possible.
Possible. All that
Well,
needed is, every time a rejection is happening, a non-conformance report must be recorded in your company.
Yes, sir.
If the practice is there to record the non-conformances, you can easily calculate the rejection rate, isn't it? Number of pieces produced and number of pieces rejected and the reasons for rejection and everything is recorded. If that practice is not there, you have to initiate such practice. Am I right? Then only you can say the problem is measurable. If you people are not recording any non-conformances, but you only work on reducing the rejections, and you will not be able to actually fix the problem, because what gets measured can only be improved. If something your department or your organization as a whole, if they are not measuring, and your improvement efforts may not fetch the result. All of you agree with me on that?
Yes, sir.
If already the measurement is in
yes, sir.
practice, well and good. If not, you must initiate. You must ask your people to measure, monitor the rejection rate on a daily basis. The data must be made available. As soon as you initiate the project, you should initiate this also. Cross-check this also. That is called the measurability. Then achievability. The rejection rate is currently 10% and the goal can be 0%, but make sure it is really achievable. There has to be some logic in setting the target. If 0% is achievable, yes, write 0%. Otherwise, you say that current rejection rate is 10% and now your goal has to be less than 2%. There has to be some logic. There has to be some kind of what do you call the reference available while setting the target. Like the industry practice, all normally all let's say all industries, similar industries, maybe a garment industry, the rejections are normally less than 2%. But in your company alone, it is 10%. So it is quite logical to set a target of 2% or below 2% when the current rejection rate is 10% or whatever. Because it's very evident, right? Many you can easily find those information by referring to certain data. There are research papers, which can talk about, the some kind of the trend in the industries. So this is some kind of benchmarking, some reference study, or in the past, or the other department might be maintaining, lower rejection rate. Only your department is maintaining 10%. You can correlate and then make it a logical thing, right? That is called achievability. And finally, time bounded. Any project, you must declare the timeline, how many months you are going to work. So the goal statement is ready. Now coming to the next one, which is scope statement.
Scope test statement.
What is the purpose of scope statement? What is the purpose?
It indicates the possibility of the successment of the projects.
Scope
That
statement
means scope.
basically states for whatever
Current state to
boundary. It creates the boundary where we have to work on.
conditions.
Very good. The boundaries must be visualized.
Describes
It is always a good idea to work on a specific problem, not on a generic problem. It is always a good idea to work on one particular problem at a time, not too many. If there are too many problems you want to fix, then initiate too many projects, not just, fix everything in one project. All right. Let's say, probably you might have discussed about the rejection in a garment industry, right? If there is a rejection in a garment industry, first try to identify which particular garment the rejections are happening at a higher level. Is it shirts or is it pant or is it your kurta or is it your churidar? You need to know that information, yes or no?
Yes.
The moment you realize, yes, it is the shirt section which is producing more rejection and your entire scope is, restricted to the shirt section only. You don't have to worry about, other sections. So scoping your responsibility is very, very important for the success of the project. If you don't scope it properly, then you will try to do everything and end up achieving nothing. So the third section. After identifying the section means department, right? And in that section, you are producing shirts. And within the shirts, how many defects are happening? Hundreds of defects are happening. Do you want to fix all hundreds of defects in just one project?
no.
What
No,
is the
No,
specific
sir.
defect you want to fix? There can be different issues, stitching issues. There can be coloring issues.
Coloring.
There can be some stains, right? And there are so
Cloth
many things
quality.
that, yeah,
Yes.
the different ways of non-conformances. And assuming the buttons attached to the shirts having a problem. So the you are trying to address an issue related to the buttons, right? Buttons are getting stitched and finally, no, they are getting rejected in the quality check because buttons are not aligned properly, because some of the buttons are damaged, because the stitches in the buttons are not as per the requirement. These are the possibilities of, the buttons, creating a problem. So you have to clearly, understand the scope. We are going to work in the shirt section. We are going to particularly arrest the issues related to the poor quality of the buttons, right? Once you come up to this level of specificness, you will have the advantage of understanding the process which is responsible for the problem. Am I right? Now that you
Yes.
understood, problem is button getting stitched to the shirts. Now tell me which is the process that requires your attention and improvement.
Stitching, sir.
Stitching of the buttons, very clear.
Teaching.
Stitching of the buttons is the process that is, creating all the trouble. Now you just have to identify where exactly the buttons are getting stitched in your shirt section. Definitely there will be one place where the buttons are getting stitched. Can you go and stand in that place for 30 minutes?
Yeah. Yes, sir.
Definitely, right? And just
Yes.
observe what is the starting point of button stitching process. What is the ending point of button stitching process? Will you be able to identify and write it in your notebook, diary?
Yeah, yeah.
Starting point of the
Yes, sir.
button stitching, ending point of the button stitching.
Uh,
Everything that is happening between the starting and ending point is coming in the scope of your project. Everything happening, before the starting point and after the ending point, that is not in the scope of the project. Also try to identify few critical steps, few important steps that is happening between the starting and ending point. Just 3 to 5 steps. How many steps? 3 to 5. In some cases, even identifying 1 or 2 steps is also okay. So start point is clear, end point is clear, and 3 to 5 important steps in the process is also made clear. This much information is good enough to develop a CpCpK later on. Clear? To develop a CpCpK later on. So only after doing all these things, you should write the scope statement. right?
Yes.
And then another advantage of doing this exercise is you can form a very effective team members. Now, since that you identified the process, you can also think about who are all involved in that process. Yes or no?
Yes.
There are people who are actually involved in the process. Some operators attaching the stitching the machine. There is a line supervisor. There is a shift manager, and you are also there as a project leader, Six Sigma green belt or a black belt. And all the parties who are directly, indirectly involved, first you make a list of all of them. That list of people are known as stakeholders, as far as your project is concerned. This is known as stakeholders. Just check. Just just ask yourself, are they all of them are ready to help you? Are they all of them are ready to help you? And some of them, may not be having, willingness to help the project team. Some people may not be interested. Some people may be interested. Some people may be dead opposite. They would like to see to that and your project, is a sure shot failure. You need to know that. Yes or no?
Yes, sir.
Yes.
So the stakeholders who are all positive, who are all negative, who are all neutral, you should know. And if the people who are negative, if they are also influential, then you have to be extremely careful. Yes or no?
Yes.
Some people are influential, and then at the same time, they don't want your project to be a successful one. So little bit of stakeholder analysis and action plan is required at the time of drafting your project charter itself, so that you can clearly, decide whom to be included as part of the project team and whom not. Some people who are really influential, their support is definitely needed for you. Yes or no? Their support is definitely needed. Somehow
Yes.
you try to, make them part of your project. If they are ready to support, then it's a blessing. He is influential at the same time, he is ready to support. If he is not ready to support, somehow, you should find a way to motivate him, and then, you should be able to get his support for your project. So this is known as stakeholder analysis and stakeholder management. It's nothing but a simple Excel table. That's all. You're writing all the parties' name, and then your next column you are writing down whether he is willing to support or not. What is his attitude? He is positive, negative, or neutral? And then what is the influence? What is the influence? And then the third thing, how he will be impacted based on your project result. If your project result is successful, certain stakeholder will be beneficial for certain stakeholder, it will be beneficial. For example, the operator who are involved. If your project succeed, will it be helpful to the operators?
Yes, sir.
Definitely, because they are no more producing rejections. They are no more
Yes.
producing defective items. So they will get paid better. Their motivation level and their morale will be higher. They become eligible for promotion and other things. So you need to understand how the project will impact each and every stakeholder. Accordingly, some sort of action plan you can make, and then and make sure at least 75% of the stakeholders are supporting your project. Then only it's a good to go scenario. Clear?
Yes, sir.
Yes, sir.
This is, and the understanding the scope is only making you think all of this. Otherwise, you will not be able to judge all of these things properly. The scope statement, you have to really do some work, and then I'd write down the in scope, out scope, and the process starting point, process ending point, key steps happening in between the starting and ending point. And so whoever connected to the process, all of them are stakeholders, and that you can do. And then you can proceed with the timeline. What is the starting date? When are you going to get the project charter approved? The completion of define, measure, analyze, improve, control. And then once the project charter is approved, yes, project is live. And over and above CpCpK. You might have studied CpCpK also, right? First, you start
Yes.
with the process. You already written starting step, ending step, and some important steps in between. Now, every step, what is the output expected? Every step, what is the output expected? And who will be receiving that output? In order to produce that particular output, what are the inputs required and who will be supplying those input? The person who is or the person or the department supplying the input should be marked as the supplier. The person or the department who is receiving the intermediate output should be marked as customer. All right. So all the persons you see on the left side, they are the supplier, and all the persons you see on the right side, they are the customers, nothing but the stakeholders. Isn't it? One way or the other way, they're all the stakeholders, isn't it? So supplier is not always, someone outside or not always someone, who is sending raw material from the Japan. Maybe sometimes, suppliers are, internal, right? Any process, sometimes what happen, your process will receiving the input from the previous process. So the previous process act as the supplier and
Yes.
your process becomes the customer to the previous process. Understanding the interrelationship between the process is important to recognize the presence of the internal customer. All of you, can you see that?
Yes, sir.
Otherwise, we always think about end user and forget all the internal customer, intermediate customers, and without respecting the needs of the internal intermediate customer, how can you fulfill the end user's requirement? Not possible. Correct? So,
Yes, sir.
all this, thinking has to happen in the defined phase. And then if you have a proper plan, create a kind of, team structure, you can show all the photographs of all the people and show who is the sponsor, who is the champion, and who is the project leader, and who is the consultant or subject matter experts involved, and who is the process owner, who are the team member. Put a nice photograph and then, paste it in the notice board where the project is happening. People, by seeing that every day, they will be motivated. Yes or no?
Yes,
Yes,
sir.
sir.
If you see your photo as the project leader, then you will think about at least spending, doing your part properly. And also, if you do all this exercise, you will also be able to write down the responsibility expected from each and every stakeholder. Yes or no?
Yes, sir.
Yes.
You can
Yes,
even
sir.
prepare a role and responsibility card for every individual, and then you can give it to them, or you can take their signature. This is what I am expecting from you as part of this project. You are supposed to, collect the data, this particular data every day. Once in 4 hours, the data must be collected, and then it should be made available in an Excel sheet, something like that. What is the particular person's responsibility in your project? That is also created so that there are no disappointments later on, right? So all these documentation, yes, definitely can help. And once this is done, define is over. Now then you are ready to move on to the next phase. What is the next phase?
Major phase.
Measure.
Measure phase. Now
Measure.
what is your objective now? Define phase objective is met.
Yes.
Ultimately, at the broader sense, the objective of define phase is get your project approved by the sponsor. And the output is approved project charter. In measure phase, what is your objective? Why we have a measure phase? Come
We
on.
have to understand the we have to collect the actual data for the analysis purpose. So that major phase is important for the analysis purpose.
Measure the baseline performance.
Very good. Measure the baseline. You have written something in the define phase, isn't it?
Yes.
You said rejection rate is 10%, rejection rate is 8%. You said the turnaround time is, 18 minutes. Something you have mentioned, but you want to reduce the turnaround time from 18 minutes to less than 5 minutes. But is it really 18 minutes? Is it really the rejection is 10%? How did you mention those numbers in the define phase? You might have used the existing information, yes or no?
Yes.
You might have used the existing information, past record, past data, using which you have concluded that this is the intensity of the problem. But what is the actual intensity of the problem?
So
Now you must,
we have to also validate the measurement system.
yeah, correct. I'll come to that. First, you have to validate your
Validate.
problem statement. In the problem statement, you have written the current state of the problem, yes or no? You have
Yes.
stated rejection rate is 10%. You have stated turnaround time is 18 minutes. You have stated surface finish is poor. Some number you have indicated. Is this number accurate or not? Yes or no? That number must be accurate. You can't, simply people are telling and so you have written. So you have to verify the current level of the pain metric. Verify. If it is
Sir,
correct, you don't have to make any
sir.
changes.
Less variation.
Yeah.
Hello.
If it is correct, you don't have to make any changes. But if your data is giving a different picture, and now you have to update your project charter. Say, for example, rejection rate is marked as 10%. But your data, you collected data for, let's say for 1 week or 10 days, you collected data. And now this data is telling you that the rejection is not 10%, the rejection is actually 15%. Now, which one you should show it in the project charter? 10%, you will continue with the 10% or you want to update it to 15%?
So we have to update to 15%. But
You
sir,
have to
the
update.
point
So
is,
business case will be much more better.
sir,
We have to take the actual data.
excuse me,
To
sir,
take
the
the actual
point
data,
is
yes.
if we got to know after measuring the data and we got to know that it was not a 10%, it was only 5%. And
That
whatever
is also
saving
possible.
yeah, and whatever saving we have showcase in our business case, that will not be happening. So at that
Correct.
time
Both
we
are
will
possible.
revise the
Both are
process.
possible. It can be 15% against the 10% what you have mentioned in the project charter. Sometimes it can be just 5% against, the 10% you have mentioned in the project charter.
But sir, the point is when we revise our project charter also, and we will again go to the management, then there will be it will be a awkward situation or not, sir, because the management will ask you, you did not have the clear picture, and now you are
But see, you are right. And if you really wanted to overcome that scenario, then you have to do define and measure together.
yes,
In such scenario, define and measure together. But normally, no. If you actually spend too much time in developing a project charter, and that is also not good, right? And that's why we develop the project charter, and then we try to validate the problem by by referring to the actual data. So both way it is correct, but if you really wanted to combine define and measure and take the approval in one go, that is also good. If the situation demands, do that. Otherwise, nothing wrong in updating, right? So you collect the data and then verify the problem and then update your problem statement accordingly. Earlier you mentioned 10%, now you have to go back and then make it as 15%, and so the business case will get updated. There are certain things, the budget and all those things, slightly there will be changes. If there is a major change, then only reapproval is required. If it is a positive change, no problem. It can be other way also. Let's say the rejection rate, is recorded as 10%, but reality, the reality is just only 2% is the rejection. Now, what is this scenario?
we have to go further to the management to reapprove after
Reapprove. But what is the scenario is telling you? People are telling that there is 10% rejection, but when you go and check, there is only 2% rejection is happening. Problem do not exist. Can you see that?
yes,
People are simply creating problems by wrongly classifying good product as bad. Can you understand that? This is
yes,
also possible.
Yes,
Yes
sir.
or no? Do you get this
Yes,
point?
sir.
That means problem is with the measurement system, nothing to do with the process. Your process is performing well. Your process is performing well, but people don't know how to measure, or they have a poor measurement system using which they simply classify even the good product as the bad product. In such cases, project will be stopped by correcting the measurement system. That's all. You don't have to make any changes in the process. Am I
yes.
correct? So this is the purpose of the measure phase, right? The purpose of the measure phase is first of all to validate the problem. Once for validating the problem, you must first have a proper measurement system. If you have a doubt about the measurement system, first you validate the measurement system. If you have a doubt, suppose you have a sophisticated measurement system, all the data is captured already. No, with some proper, what to say, in a, let's say you have some kind of, digital system. You have sensors and they capture the live data in a very accurate manner. Because only if human beings are, involved, then the chances of error will be more. All of you agree?
Yes. Yes. Agree.
If you have systems in place, let's say some electronic systems, sensors, and the computers are connected, so data is getting recorded, automatically. So you can trust the measurement system. In those cases, you don't have to check whether the measurement system is good or not, provided you have confidence on the measurement system. At the moment you understand your measurement system is weaker because a lot of mechanical components being used. Mechanical components, there will be wear and tear. And if there are a lot of operators involved, human beings involved, and they might behave in a biased manner certain times. Some people may not know how to use the measuring instrument, but still, they will use it and then produce the data. So error is possible. In those scenarios, you must validate the measurement system.
Sir,
All of you understand when to go for a measurement system validation, when not. When measurement system validation is not required, if you are very, very confident and sure that you have a strong measurement system in place, you don't have to doubt, isn't it?
Yes.
Yes, sir.
So, but the moment you have some sort of doubt on the measurement system, nothing wrong in proceeding and validating the measurement system. And for validation of measurement system, you need to know what kind of data your measurement system is dealing. You need to know what kind of data your measurement system is dealing. Your measurement system might be dealing with some continuous data or measurable data or variable data. All are same. What do I mean by continuous data, measurable data, or variable data? What does it mean? Please confirm. What does it mean by continuous data?
Value with decimals.
Decimals. Very good. Good observation. Decimals. But the definition is still not complete. What is measurable data? The term itself has a meaning. It can be measured using a measuring instrument.
Dimensions, sir. Dimensions.
Will you be able to measure your body weight?
Yes,
yes,
sir.
sir.
Yeah.
You have a measuring instrument, right? You might have a weighing scale in your house. If you stand up on it and then it gives a reading, the reading comes in decimals. Not only that, it will give the reading with the appropriate unit of measurement. Have you noticed
Yes, sir.
how your weighing scale will weigh your body? Will it give the reading in kilograms?
Yes, sir. Kilograms.
The presence of an unit of measurement confirms that your data is continuous data. Your data is variable data. Your data is measurable data. That means it is in its purest form. Data is in its purest form. Whatever is the measurement system, level of accuracy possible in the measurement system, yes, that will come. Chances of human bias will be minimal. Yes or no?
Yes, sir.
Right,
Chances
sir.
of human bias is
Yes, sir.
minimal. But in certain cases, the chances of human bias will be high. They are known as attribute data or discrete data. Say, for example, all of you are giving a rating for the training program at the end of every session. We post a feedback form and ask you to fill up on a 5-point scale. If you are in a good mood, you give 5 out of 5. Suppose if you are in a bad mood, urgency, you may choose one number randomly and then go, isn't it? Now, the chance of bias is very high. That is the difference between measurable data and attribute data. Rounding off can happen in the what do you call the attribute data. However, in a continuous data, since decimals are possible, you can express those values in decimals only. Right? If I give you a weighing scale, you will tell me, sir, my weight is 71.53 kilogram. If I don't give you the weighing scale, you will tell me, sir, my weight is 72.
Exactly,
Can
sir.
you see you are rounding up, isn't it? So that is the problem with attribute data. So which data is better? Continuous data is better, measurable data is better. And the attribute data is also known as discrete data because always, the appraiser always express the data only in the predefined values. For example, while rating our training program, you will always give 1, 2, 3, 4, or 5. Only one out of the 5 values will keep on coming from all the appraisers. Yes or no?
Sir.
1.5, 2.5, 1.75, 8.5, all these things are not possible. Only discrete number of possibilities are there. That is why it is known as discrete data. Whereas in a continuous data, anybody can give any value. That is decided only by the limitation of the measuring instrument. Yes or no?
Yes, sir.
If the measuring instrument can give 2 decimals, if you try to write all possible values of 2 decimal, no, you will run out of the pages. You can't write
Yes.
down everything, isn't it? 71.11, 71.12, and then after that 71.21. You can't write down everything. Infinite possibilities are there. That is why we call it continuous data. You need to know what kind of data you are dealing. Will you be able to find out here after all of you?
Sure, sir.
Yes, sir.
Sir,
Suppose, yes.
so this type of data is, as you said, na, continuous data. This type of data is the more complicated to handle.
No. Which type of data is better to have? Continuous data is better to have. Wherever possible, try to use continuous data. You want to understand the speed of the motor and now speed of your ceiling fan. Somebody will say, my fan speed is very high.
Okay.
But one can always use a tachometer and then say the speed is 1482 RPM.
Okay.
Which is better? Somebody saying very high is better, or somebody is telling that 1483 RPM is better.
RPM is better.
RPM is the unit of measurement. Can you see that?
Yes.
When I say high speed and there is no unit of measurement. So your reading can come without an unit of measurement, which is then only just a dimensionless value. But your reading can always come with a unit of measurement. If it comes with a unit of measurement, it makes more sense in your project. Correct?
Yes.
So you must look for continuous data. The moment you know data is continuous, there is a standard procedure to validate your measurement system. If you are dealing with attribute data or discrete data, like data is always classified as high speed, low speed, and medium speed. High speed, low speed, medium speed. How many values are possible? Only 3.
Right.
Yes.
Everybody recording the data, they will only record low speed, high speed, medium speed. So now this kind of data are known as attribute data. For attribute data, you must perform attribute agreement analysis. But for continuous data, you must perform gauge R&R study. But always the preferred data is continuous data.
Okay.
Wherever possibility is there to work with continuous data, you must prefer to work with it. You must prefer to collect continuous data. Clear, all of you?
Sir, can we say qualitative?
you have done?
Gauge
Attribute-
R&R study. Gauge R&R study. In general, it is known as measurement system analysis. But for attribute data, it is attribute agreement analysis. But for continuous data, it is gauge R&R study. Ultimately, what are we interested in? What are we interested by performing the MSA? We are interested in knowing the bias. We are interested in knowing the bias in our reading. Because more the bias, more chances are there for your decision to go wrong. So what is bias? Can one of you answer this question?
Sir, can we say
Difference
attribute data
between
is
true value to
qualitative
observed
data?
value.
The difference between the measured value with respect to the absolute value.
Observed value.
Very good. Difference between the true value and the measured value. This is known as
Measured
the
value.
bias. To the extent possible, bias must be eliminated. If you can't eliminate, the bias must be less than 10% of the working range. Should be less than 10% of the tolerance provided by the customer. Bias should be less than 10% of the tolerance given by the customer. What is tolerance given by the customer? Upper specification minus lower specification. That is known as the tolerance provided by the customer. All right.
Yes.
In any scenario, you should be able to identify the upper spec and lower spec. Then only the CTQ is considered to be defined. Then only CTQ is considered to be defined.
Define.
Yes or no? You are
Yes.
working on time delivery. Then what is the on-time delivery percentage expected by the customer? Customer will always say minimum 95% on-time delivery should happen. So minimum is 95, maximum is 100. Anything below 95, not accepted, right? It's a one-sided specification.
Sir,
So any requirement, there should be upper spec and lower spec.
excuse me, sir.
Hmm.
Sir, how is there any bias in the data? How is identification? Is there any specific?
Yeah, I'll tell you. So bias has to be calculated. First, the requirement is bias should be less than 10% of the tolerance provided by the customer. For example, you are working on a project where the dimension of a product must be, within the spec. The required dimension is 100 plus or minus 0.5. Now, what is the upper spec?
100.5,
So lower spec is
95.
99.5,
95.
99.5. So what is the tolerance available?
1 mm,
1 mm. How much is 10% of 1 mm?
0.1.
0.1. So the readings that your measurement system is bringing can have a maximum error of 0.1 mm only. Can have a maximum error of 0.1 mm only. So the resolution of the measuring instrument needs to be understood. If this is the requirement, the resolution of the instrument needs to be understood. All of you, do you know what is the resolution?
The least count.
Very good. Nothing but the least count. So every measuring instrument has got a least count, isn't it?
Yes.
So the better the least count, but no, the lower will be the bias. Better the least count, lower will be the bias. So you need to know what is the resolution or least count of any measuring instrument that you deal with. I hope all of you have a smartphone, and in the smartphone there is a stopwatch. Yes or no?
Yes.
Yes.
Please open the stopwatch and find out the least count. Come on, all of you, open your stopwatch. Open your stopwatch and find out what is the least count. You all know what is the least count, right? The lowest signal to which the instrument can respond, right? Please find out what is the lowest reading that is possible.
Seconds.
That's what. How
Milliseconds.
many seconds?
Milliseconds.
Microseconds.
Milliseconds.
And somebody has typed the answer in the chat box. Yatharth Agarwal. 0.01 second. That is the correct answer.
Yes.
0.01 second. 0.01 second is nothing but 1 by 100th of a second. That is the resolution possible from your stopwatch, right? Millisecond means
Yes, sir.
1 by 1000th of a second. But what is the resolution we are seeing? 1 by 100. It is better to use the language which we are familiar with. Yes or no? If I know English, then I should speak in English. If I try to speak in Hindi, you know the situation, isn't it? So we are very comfortable with seconds. So express it in seconds. You don't have to unnecessarily complicate the situation using other units, milliseconds, centiseconds, nanoseconds. So many seconds are there. Yes or no?
Yes.
If you are familiar, use them. Otherwise, just say 0.01 second. If you wanted to express it using the other method, you have to say centisecond, not millisecond. All right. So it is better. Let us use 0.01 second. Very good. So the resolution has to be understood. That is one thing. And then bias has to be understood. Please note, there are your readings can have a bias because of several reasons. Because of several reasons. If there is a problem with the instrument, there can be a bias. Yes or no?
Yes.
Yes.
If people don't know how to use the instrument, then also there can be a bias.
Yes.
So you need to understand whether the problem is with the instrument itself. If the problem is with the instrument itself, then you have to calibrate the instrument. Yes or no?
Yes.
Then you have to calibrate the instrument. But if the problem is not with the instrument, then you have to understand that People don't know how to use the instrument, and that becomes a part of study known as the gauge order study. What I'm trying to say is the bias is a result of either poor condition of the measuring instrument or poor condition of the measurement system as a whole. If the instrument alone is the problem, you can calibrate. If people also part of the problem, will you calibrate people also? There
No,
is no procedure
we can
available,
just
right?
train them.
So you can only conduct some training and give them some piece of advice and give them some kind of extra assisting device. That's what you can do. So there are two components responsible for the bias. One component is the equipment. Another component is the whole measurement system. Am I right?
Yes, sir.
Now, if I ask you what is the time now, you have already have a mobile phone. What is the time now?
7:53.
753.
All of you are telling 7:53, isn't it?
Yes, sir.
Now there is a consistency in the reading. This is the primary requirement to consider a measurement system as a proper one. Primary requirement, there must be consistency. If one person is telling 7:53, another person is telling 8:53, another person is telling 9:53, we cannot work together.
So because
Yes or no?
all are looking the time from mobile GMT ways.
That's correct. No, that's what we have. All of us have a similar measurement system. All of us have a similar understanding. That is very important.
Right.
That is why operational definition comes into picture. Anything you are dealing, you have to define it in 2 lines. If you say turnaround time, you have to clearly tell your people what is the meaning of turnaround time. They should not go to dictionary or they should not go to Google to understand the meaning of it. You have to give it as part of your project, isn't it? That is known as operational definition. Otherwise, getting the consistency will be a problem. If consistency is not there, that become a reason for the bias. How many of you understand? If consistency is not there, that will become a reason for the error. Yes or no?
Yes, sir.
Okay,
Yes, sir.
so first reason for the bias is poor consistency of the measurement system. First point. You can control this, you can control this error by way of strengthening your measurement system. And in order to strengthen the measurement system, you should understand all the elements of the measurement system. First of all, the measuring instrument is part of the measurement system.
Yes.
Your operator or the person who is collecting the data, appraiser, he is also part of the measurement system.
Sir, I have a live example yesterday with this measuring system.
Mm.
Actually, my mother have a high blood pressure, right? So when I went visit to the doctor, so sometime mother checked their BP blood pressure from the left hand or right hand, right, in that way. So now doctor says that only at a sharp 9 a.m. with right hand only, so that reading can be controlled, sir.
That is called operational definition. If you don't follow the operational definition, and you will get a different picture about the problem.
Right.
Right? Operational definition. Suppose you are working on a weight reduction project. You want to reduce your weight. Then you must have an operational definition for your body weight. Yes or no? You can't simply take your, measure your weight, whenever you want. That is not going to help you, isn't it? If you take one full plate of biryani, then your weight will be extra 1.5 kg. You're not supposed to measure, in that time. A predefined definition must be available. Every day, early morning, empty stomach with light cloths around 7 o'clock. This is the operation definition for people who are working on reducing the body weight. If this definition doesn't exist, every day you measure in different manner, the data is not going to help you. Clear, all of you? So controlling the bias has got two components. First component is you have to achieve the consistency. In order to achieve the consistency, the measurement system should cooperate, operator should cooperate, the kind of product you are measuring, the characteristics you are measuring, that is also part of the measurement system. Particular product that you are holding and then measuring, isn't it? That is also part of the measurement system. You need to understand. Certain products are easy to handle, certain products are difficult to handle, and so your readings can go wrong. Very, very small component when I give you, you will struggle a lot to measure. Understand? And then the characteristics. What characteristics? That is also part of the measurement system. The environment is also part of the measurement system. The kind of instruction, operational definition I give you, that is also part of the measurement system. If any of this thing is weaker, it becomes difficult to produce consistent reading.
And selection of instrument also will matter.
Yes, yes. Yeah, instrument is part of your measurement system. See, consistency itself will get damaged if you have, a weaker element. If I give a wrong definition, then if I simply ask you to measure measure the temperature of the boiler, one person will switch on the boiler and will take the reading immediately. Other person will switch on, wait for half an hour to stabilize the boiler, and then only you take the reading. Third person will switch on and take the reading after 15 minutes. Are they taking the reading properly?
No, sir.
Each one is following, their procedure. People following different procedure for collecting data. How can the reading be consistent? So the reason for the bias is poor consistency in the data collection procedure. All of you understand?
Yes, sir.
First, you must fix this. After fixing this only, you must try to fix the bias. If consistency is not there, nothing will be achieved. In order to bring the consistency, we write the operational definition, right? In the absence of which consistency will be a big trouble, right? So whether our measurement system is capable of giving consistent reading or not is what is getting assessed by gauge R&R study.
Excuse me, sir.
Yes.
Sir, as you said, in the data there should be consistency, right? But if
Yes.
sometime it's seen that from data is captured by the manually, right? From 0 to 5, and operator just put the 3, 4, 3, 4. This is a random scenario. So this is also bias in the data because their mind is reading between the 3 to 4 basically. So he always put in all the shift 3 to 4.
That's what, see, you are not supposed to simply put the 3 and 4. Whatever is the, procedure that must be followed, and whatever is the reading comes, that must be recorded. We can't put, whatever we want. This is what I am calling, biased behavior. Ultimately, everything will add up to the bias. First of all, consistency is the key. You have to bring consistency, right? So let me show you, play a video here to help you understand the importance of operational definition. Why people collect the data in different manner? Because there is no clarity in the data collection. Yes or no? And whose responsibility is to bring the clarity in data collection? Who is responsible?
We as a
Obviously,
manager.
the project leader. You are responsible, isn't it? So if you don't provide an operational definition, or you give a wrong operational definition, people will definitely be, guided wrongly, and then the consistency will be lost. If consistency is lost, automatically accuracy will be lost. If consistency is lost, accuracy will be lost. Let me play a video which can help you understand the consequence of having a poor operational definition. Poor operational definition means, first of all, it is not clear. Secondly, it is not concise. Thirdly, it is not unambiguous. The instruction must be clear, concise. What is the third one? Unambiguous. It should not be confusing, isn't it? Such instruction must exist.
No
He has not
clarity.
given a clear instruction. He has not given a clear
Yeah.
instruction.
Information is not clear, and there is a chance for ambiguity. He says my computer, and he understands something else. This
Communication
should not
error
be
is
the
also there.
scenario. You have to use the right choice of the words, visual clues, sample pieces, training, do everything. Then only consist. If you are completely unaware of the problems that can come from the poor consistency, it simply means, if you don't understand, if you don't think about the problem of inconsistency, it means you have decided to close your eyes and continue driving your car. What will happen? You may not reach the destination, isn't it? You are not able to get a clear vision of the road, but still you want to drive. For driving anything, you first of all should get a clear vision, isn't it? What is there in front? So same is the thing. So first you must achieve the consistency. Only to achieve the consistency, we are performing gauge R&R study. Clear?
Yeah.
And gauge R&R study, there are two components we are focusing on. One is repeatability error, another one is reproducibility error. Do you know that the difference? What is repeatability error? What is repeatability error? Repeatability error
Repeatability is
means
the error which when we measure a component for repeatedly, and if we are not able to, sorry,
One appraiser.
yeah, one appraiser and
When a, when a
One
single
appraiser
person
can
can
do
take
the
the
multiple
readings.
multiple observations are being noticed when a single reader is measurement is taken.
okay. I will just summarize. One appraiser or one measurement system measuring the same part repeatedly, but readings are different. One appraiser, just one measurement system, because I have one instrument, one appraiser, one part. I measure it repeatedly, but my readings are different from each other. Maybe by a small margin, maybe by a big margin. If it is by a small margin, okay, you can tolerate to certain extent. The 10% margin is there. Can you remember? If the variation is within the 10%, okay. But if it varies by a huge margin, it will become a big headache, similar to the video you have watched. Yes or no? So repeatability error means the inconsistency within the readings of the single appraiser. All right? The variation, or in simple words, the variation within the readings of the single appraiser while measuring the same part multiple times. This is known as repeatability error. Now there is another error, reproducibility error. Reproducibility error means we have two measurement system. Imagine I am an appraiser and you are another appraiser. We both are measuring the same part. We both are measuring the same part, same characteristics, but my reading and your reading are different. My reading and your reading are different. But what is that we both measured? Same product, same characteristics. How can the reading be different? If our readings are different, they are not agreeing to each other, then the error committed. Then this form of inconsistency is known as reproducibility error. Whenever two or more number of measurement systems are used, reproducibility error must come into picture. Whenever you repeat the experiment, repeatability error will come into picture. Yes or no?
yes.
Yes.
You must consciously control both of them. You must consciously control both of them. Then only consistency is possible. And now somehow, if you could quantify them, then there is repeatability error and there is reproducibility error, right? So let me write something now. So I'm just taking a board. Yeah. So now there is a repeatability error. Repeatability error. Let me call it as delta repeatability error. Repeat. And there is one more delta possible, which is delta reproducibility. Yes or no? This delta capital R and delta small r. Capital R is repeatability error. Small r is reproducibility error. When I sum them up, this is known as precision error. What is this known as? When I add them up, this is known as precision error. So what is precision error? Sum of repeatability error and reproducibility error. Now I want you to find out the ratio. your precision error, oh God, what is this? Your precision error, must be divided by tolerance. The precision error must be divided by tolerance. That means you have a ratio now, P by T ratio. What is P? Precision error. What is T? Tolerance. Tolerance you already understood. What is tolerance? USL minus LSL. Yes or no? This P
LSL.
by T ratio, if you multiply by 100, then you will get the P by T ratio in terms of percentage. This P by T ratio expressed as a percentage is known as gauge R&R. How many of you understand? All of you understand this?
Yes, sir.
Sir, can you
Yes,
explain
sir.
once again? Sir, can you explain once again? Sorry.
Precision error is nothing but repeatability error plus reproducibility error. Repeatability error plus reproducibility error. Sum of repeatability error and reproducibility error is known as precision error. This precision error must be compared against the tolerance provided by the customer. Please note the tolerance is nothing but very simple, USL minus LSL. USL minus LSL is the tolerance. You are comparing again. So you get a ratio. And this ratio, you can also multiply it by 100 so that you will get it in terms of percentage. Please note, for any measurement system, the gauge R&R must be less than 10%. Am I right? I don't know why it is not. Okay. So the gauge R&R must be the gauge R&R. No, there is a problem today. I don't understand. Yeah. So the gauge R&R must be less than 10%. All of you understand this is the requirement. Then your measurement system is acceptable.
Yes.
If the gauge R&R is more than 30%, the measurement system is unacceptable. It is very risky to work with such a measurement system. Please note. If the gauge R&R is more than 30%, measurement system is unacceptable. What if the gauge R&R is between 10 to 30%? Between 10 to 30%, conditionally acceptable. Clear, all of you?
Yes.
10 to 30%, conditionally acceptable. What is that condition? Yes?
It's called NDC.
No, not NDC. I'll come to that. Conditionally acceptable. Under what condition you can accept that? If your process
We have to.
capability is on the higher side. Yesterday
have-
you might have discussed about CpCpK.
Yes.
If the process capability is on the higher side, then gauge R&R of 10 to 30% is acceptable. If the process capability is weaker, 10 to 30% you are not advised to use. Do you understand, all of you?
Yes, sir.
In terms of capability, if you have higher capability, then 10 to 30% is okay. Otherwise, it should never come into picture. You should always ask for less than 10%. Clear, all of you? And now we will do a small exercise to check your understanding. To check your understanding, we'll have
How much capability should be achieved? Means 1.67 or more than 1.67?
more than 1.67 is preferred.
Okay.
For more than 1.67, the second condition can be accepted. Otherwise, no. Right? So you will definitely slowly, you will be able to understand all the logic, on your own. Now, let us do a small exercise. So your attention to a different direction. So now look at the chat box and tell me, are your readings are consistent first of all? Or are you lagging in terms of the consistency?
Inconsistent, sir.
Inconsistent.
Now, what is this error called?
Inconsistency.
How do we name it? How do we name it? Is it
Reproducibility.
repeatability error or reproducibility error?
Reproducibility.
Reproducibility error. Even though all of you are given the same instruction, all of you have listened to the same song, but still the readings are differing, right? But differing by a small margin, that is okay. Because we have some guideline, less than 10%. The bias at the maximum should be less than 10%. But in spite of my instruction, can you see some people recording the data in minutes and all?
Yes, sir.
Finally, after everything goes to the Excel sheet, computer cannot understand your language. Computer can only understand, everything, will consider everything as seconds because it is programmed for seconds. Please note. So it is your responsibility to convert everything into seconds and then use it. So what we are experienced here is a form of reproducibility error. How much error you all have contributed? Do you think I will be able to quantify?
Yes, sir.
Yes, sir.
Possible. What I need to do is I must capture all your data, put it in an Excel sheet. I must calculate a standard deviation out of it. I must calculate a standard deviation out of it. You all know how to calculate standard deviation, am I right? Will you be able to calculate standard deviation using Excel? Possible, easy, right? One thing is manually doing, and manually you don't have to do nowadays. So see here, there is an Excel sheet. Can you see my Excel now?
Yes, sir.
Yes, sir.
So I can simply type all your reading, you have given 72.32 and 76.87, whatever. Likewise, so many readings. All your readings are captured, all right? And now I need to calculate the standard deviation. So yes, Excel has got a formula, isn't it?
Sir.
You simply, select everything. Now, what is the standard deviation?
20.4.
20.4 second is the standard deviation. And now you just have to multiply this by 6. This much error, 122 seconds is the total error contributed by the measurement system right now in the form of reproducibility error. All of you understand there is a way by which we can quantify everything. And the secret for, see, please note, for all the problems the problems will appear as variation in your data. Yes or no? If you people don't make any mistake, let me show you the same action. Let us say all of you are working consistently. All your readings are exactly 72 points. Let us see what happened. All your readings are exactly 72.32. Now, what will be the standard deviation? Even without even calculating, you can tell yes or no. Is there any variation in the data?
No.
That means standard deviation should be 0. And Excel is giving some e to the power of minus. That is as good as 0 only. Don't worry. This is as good as e to the power of minus 14 is 0. And so if this is 0, the reproducibility error is also 0. But if there is a variation, always any problem in real life will appear in your data in the form of variation. Agreed, all of you?
Yes, sir.
If you don't have a consistent lifestyle, then your body sugar level will fluctuate. So whatever is the problem, we can see it, in our data. And if the amount of variation is too much, you can
Sir,
understand.
hi, sir.
Control is
Hello.
very, very
Hello, sir. It seems there is a background noise in between somewhere. It's happening. It's prolonging
okay.
for
From
some
whom
time.
who is having the background noise? Okay, I will try to mute. Let me find out from whom the background noise is coming. Okay, those maybe if you want to speak, I think I have muted now all of you. You have an option to press the space bar and then speak. All of you know that. You can, if you are on mute, I will demonstrate. I can press the space bar and then speak. The moment I release my hand from the... So that way, whenever you want to speak, you can speak, right? So if particularly if you have a background, otherwise feel free to unmute, stay unmuted. All right, we are talking about the way of quantifying the reproducibility error. Please note, everything can be quantified. Everything can be quantified, isn't it? So data will have variation. You quantify the variation. Trust me, the maximum variation you will be able to capture if you simply calculate Six Sigma. If you simply calculate Six Sigma, right? So now, let me tell you another thing. If I play the same song one more time for the same duration, how many of you are confident that you will produce me the same reading?
Not possible.
Not
Not
possible.
possible. That
Not
means
possible, sir.
repeatability error will also appear in our data. That means we can't eliminate, we must first of all admit that we can't eliminate population of error, particularly because the measurement system is so complex in nature, isn't it? So achieving consistency, if you take good measures to achieve the consistency, then the gauge R&R value will be minimal. Otherwise not. Clear all of you? This is called gauge R&R exercise. Now I will show you the Minitab. Today I will also share the Minitab link with all of you. You can also practice, right? So all of you, can you see my screen now? Now this is the Minitab software,
Yes, sir.
right? This is a Minitab software. And see, it has a certain area. I will show you. Yeah. So normally Minitab software will look like this. Yes, in this manner it will look. This side I can close. All right. Okay. So this is how it will look if you open it. This area where I am placing my cursor, you see, I am moving my cursor, right? This
Yes,
area
sir.
is known as worksheet. Here you can copy paste your data or type your data. Similar to the Excel, the headings must be typed in the gray row. Heading should appear in the gray row. Data must be typed in the white color area. Clear all of you? And now this area, you can see here, it is written session. So this area is known as session window. In the session window only, the reports will appear. In the session window only, reports will appear. Always when you want to conduct a gauge R&R study, you must select 10 parts. How many parts you must select?
10 points.
10 parts. 10 parts between USL and LSL. All of you understand? 10 parts covering the spread of the tolerance, USL and LSL. Minimum 10 parts, right? More is better. Minimum 10 parts. And then you have to choose the operators for data collection, right? And maybe depending on the conditions, two operator, if you are using two operator, take two. Or if there are so many people who are involved in data collection, you randomly pick up 3 from them, right? And then every experiment must be replicated. Why replication? If you don't repeat the experiment, you will not be able to judge how much is the repeatability error. Yes or no? So we have to replicate the experiment. So let us say we replicate every experiment 3 times. Now please note, there are 10 parts, there are 3 operators, and each experiment we are repeating 3 times. So 10 into 3 into 3, 90.
20.
So 90 trial readings you have to perform now. How many readings? 90 trial readings you have to perform to get an estimate of the gauge R&R. And this gauge R&R is expected to be below 10%. All of you understand? Please note, this is not the real data collection. This is pilot data collection. What is this?
Pilot data.
Pilot study. We are only doing, checking whether our measurement system is okay or not. Once we feel okay, we go for the actual data collection. Clear? Okay. Now 90 readings are required. So how to collect the data? For that also, Minitab has got a feature. I'll tell you. Go to stat. go to quality tools, then come to gauge study, right? After, oh, I'll just show, just a second. Answer. You go to stat, go to quality tools, come to gauge study, and then you come to create gauge R&R study worksheet. Can you see that all of you?
Yes, sir.
What is the description? Plan a gauge R&R study. Plan a gauge R&R study and create a custom worksheet for data collection, right? So you have to click that. After clicking, number of parts. Minimum how many I told you? 10 parts.
Yes, sir.
Now you have to decide on the operators, right? You can have 2 operator or 3 operator. If there are too many operators expected to be involved in the data collection, select at least 3. You can also name them here. What is written here? Ramu, Somu, and then Babu. Some 3 people. 3 good people are included in the study. And replication 3. If you want to increase, you can increase like this 4 or 5. And now I want 3. So 10 into 3 into 3 is 90. Now you give OK. Can you see a data collection worksheet appearing here? Can you see here, all of you? Please confirm. Can you see how many
Yes,
rows
sir.
you are seeing? You are
90.
seeing 90 rows. In this order only, you must collect the data, and the order of data collection should only be known to you, not to the data collectors. The order of data collection should only be known to you, not to the data collectors. This is to minimize the human bias, right? Minimize the human bias. And this is known as principle of randomization. Experiments must be randomized. Now the data, all the data now must be typed here. Once the data are typed, it is ready for analysis. All of you understand? I don't want you to do all these painful calculations manually. We can teach you when you really wanted to learn. Otherwise, use the mini tab, right? Now let me open some already existing data. So for that, I go to file, I go to open worksheet, go to file, go to open worksheet. And now this window is coming. Now this is a sample data folder where so many project files are available. Project data is available. You click this. Here you have to type gauge aiag.mdw. Click that and then you open. Can you see? Oh, already open. So, can you see here? Already data is fed here, all 90 data. Can you see that? All 90 data are recorded already. Yes or no?
Yes, sir.
Once data is recorded, that means experiments are over. Now the data is ready for analysis and you will get a picture of the gauge R&R. For that, what you need to do, you should go to stat, you should go to quality tools, then you should go to gauge study, then finally go to gauge R&R study crossed. What is the meaning of crossed? If the parts are common for all the operator, the study is known as crossed. When I played a song, is that the song is common to all of you?
Yes.
So the study is crossed study. Similarly, if you use 10 parts as common for all the operator, your study is also known as
Crossed.
crossed study. So I go for the crossed. Now you have to feed the data. Part numbers, column number 1. Click and select. Operator available in column 2. Then actually data measurement available in column 3. Now there are 2 methods. You can use any method, nothing wrong in it. Then definitely you go to option. You must declare the tolerance. Because we want to calculate the gauge R&R with respect to the tolerance, yes or no? So you should know the upper spec and lower spec, or at least you should know the difference between upper spec and lower spec. For this example, I am typing the difference between upper spec and lower spec as 12. After doing this, I give OK, I give one more OK. And now the analysis is done. These graphs are also plotted. And maybe at a little later stage, I will teach you how to read all these graphs. But right now, come here. Come to the session window. Can you see here session window? So the gauge R&R study. This is here the report starts. Gauge R&R study on our method. What I want is I want you to leave all of this initially. Straight away come down, come down, come down. Come to the last. This is the table I want you to pay attention, right? So this table is talking about the gauge R&R value. What is the reading? Total gauge R&R. How much is the reading? Gauge R&R value?
15.2.
15.2%. And what is the decision now? Your
15.17.
measurement system is acceptable or conditionally acceptable or unacceptable?
Sir, conditional.
Conditionally acceptable. Now, if you think, you are working with a process which is, strong in terms
15.17.
of the capability, then this measurement system is okay. Otherwise, some improvement is required. Suppose if improvement is required, how will you improve now? Tell me. You have to revisit your operational definition. Yes or no? You need to find out who is not agreeing with the team.
Yes.
You may have to train your people. All that you have to do. This is only to bring the consistency in the reading, not accuracy. Please note. This exercise we are doing only to bring the consistency. Maybe after the tea break, I will talk about the accuracy also, right? So now this is the thing. And probably this graph icon, if I click, I'll be able to see the graph also, right? This gauge R&R graph. Yeah. So this graph, if you get into the details of the graph, you will be able to pinpointedly identify who is pulling your, the gauge R&R value. Who is actually responsible for the higher gauge R&R value? How many operator you involved?
3.
3. And now I will explain only one graph. You see here. Can you see blue color boxes here?
Yes, yes, sir.
Sir,
These graphs are known as box plot. These graphs are known as box plot. One box plot is available for one operator. In the box plot, can you see a circle with a cross symbol, plus symbol?
yes, sir.
Yes, sir.
That circle with the plus is the average reading produced by operator A. The next box plot, there is next circle. This is average of the readings produced by operator B. And this third one is the average of the reading produced by operator C. Now, what is expected for a good reproducibility is all the average should be on the same horizontal line. Now tell me whose average is out of the horizontal line?
C.
Operator C, sir.
C.
So operator C has to align with A and B. Do you understand?
Yes,
So
sir.
in this manner, if you get into the details of this graph, you will certainly be able to improve your existing measurement system, but you have to work a lot. You have to identify the root of the problem and who is not cooperating and who is behaving differently. Nobody should behave differently. Everybody should follow the SOP. That's all. If everybody follow the procedure, just record the data the way it is required, then no problem of measurement error. So same manner, each and every graph can throw light, right? And similarly, one other graph which you can understand is, see here, can you see this graph? What is the name of this? Measurement part wise.
Measurement by part.
Measurement by part. You have used 10 parts. Every part is measured by each operator 3 times. So from every part, every operator gives 3 reading. Yes or no?
Yes, sir.
Totally 9 readings are coming from same part. That means all the 9 readings should ideally be same. Yes or no?
Yeah.
Yes.
If 9 readings are same, in this graph, the points will appear like a pile of coins, one over the other. But look at the way the points are appearing here. The coins are spreaded. Can you see that?
Yes, sir. Maybe.
Now, where is the spread more? Probably you can see part number 2, the spread is too much. Can you see that?
Yes,
Of
sir.
course, in my opinion, it is spreading everywhere with all the parts. Maybe part number 8, the spread is little less. Maybe part number 9 also somewhat okay. But in ideal condition, there should only be 1 point. Wherever the spread is more, that is a confirmation that your team is struggling with respect to the particular part. You may have to probably tell them how to measure. But in this particular graph, all the 10 parts equally giving the equal challenge. But in some cases, only certain parts will give the challenges, and accordingly you can train your team. So So we have to stop here, and so that you people can take some rest and then come back, and then we will continue. Is that okay?
Yes, sir.
Yes.
Excuse me, sir.
Yes.
Sir, this activity can be done on Excel also. If there is any no minute.
In Excel, we have to develop the template. All the formulas should be pre-written, and then it can be done. But if you want Excel, yes, it is possible. And hereafter, all Thursday, you all will be having one extra session. Right? An extra session is optional, only to clarify your doubts. Coming Thursday, 8 p.m., there will be a session. I will be bringing one more senior person in our team, one Dr. Ramakrishnan, right? If you need an Excel template, he will give you immediately,
Okay. So
right?
what of the
But
time,
please note,
sir?
8 p.m. 8 p.m. to 9 or slightly stretchable. So 8 p.m. the meeting will start, and we will put the details in the WhatsApp group. If you are available that time, or make yourself free and you can participate, and then the agenda is to clarify your doubts and then discuss the exam related questions. So here after now onwards, all the Thursdays will also be additional time slot. Okay, so we'll continue after the tea break. So 8:40 now. So can you come by 8:55?
Yes, sir.
Yes.
Okay.
Okay.
For me, everything is looking simple or becoming complicated.
Concepts
today
are
it is
okay.
looking
Calculations are more.
Calculations you are not going to do.
Okay.
Why do you calculate manually?
Sir,
All the
if we
tools
ask
will-
about the concept of this examination, so in the examination, the numericals or derivations will be there, or only the concept will be
See, numerical questions will be there, but you can answer the questions also using Minitab and Excel. Don't worry. We will equip you. We will equip you. Right? We'll equip you with what you call the templates and everything. Use the template. Learn to use the template. Right? And only when you want to teach others, you have to know the formulas. For that purpose, you come to our Master Black Belt program. Right? After that, you can teach others. But right now, you should be able to drive the project. That's all. You feed the data and generate the report. Just the click of the button, work will happen. You use the Minitab and generate, but you should understand the report. Oh, how the data is generated and all the logics you should know. So now that let us take it granted, we know how to conduct the gauge R&R study. Yes or no? We know how to conduct the gauge R&R study. Let us assume that we got a good gauge R&R value. That means gauge R&R is less than 10%. That means now you can perform the study for the bias. After conducting the gauge R&R study, you can study the bias. In order to study the bias, you need a standard piece now. Please note, for gauge R&R study, no standard pieces required. You can simply take 10 sample, because there we wanted to only measure the consistency, but now we want to measure the accuracy. All of you understand the difference? Earlier, our goal is to understand the consistency. Now our goal is to understand the accuracy. The closeness to the true value is known as accuracy. Yes or no?
Yes.
If the true value is 100 mm, and if you are reading also 100 mm, you are accurate. Bias is 0. Now tell me, I ask you, what is the time now? Again,
8:58.
8:58.
and the actual time is also 8:58, and you are also able to exactly point out 8:58. That means you are now accurate. All of you said 8:58. You all, as a system, you are consistent. Am I right?
Yes.
You are not only consistent, you are also accurate. All right. Suppose instead of 8:58, if you tell me 9, somebody rounding up, sir, what is the time, sir? 9 p.m. Now there is a bias in your reading. Yes or no?
Yes.
How much is the bias? 2 minutes.
2 minutes.
2 minutes extra. Your reading has got 2 units extra. This is known as positive bias. This is known as positive bias. Suppose if the time is 8:58 and you record it as 8:56, now you have a negative bias of 2 minutes. Do you understand? Why the bias is not coming here? Because you have a sophisticated instrument. Yes or no? Well calibrated. Yes or no? With a better resolution. But this may not be the scenario in your workplace, in your shop floor. Yes or no? People can bring the reading with the bias. Now, one way you people can control the bias is ask your people to measure the same thing multiple times. Yes or no? Ask your people to measure every reading at least 2 times. If every reading, if they take at least 2 times, you can use the average instead of using the individual value. This will minimize your risk of using a biased reading to a certain extent. Yes or no? Logical? Any reading your people are taking, let's say boiler temperature has to be recorded. Instead of taking just one reading, ask him to take the reading 2 times. Clear? If there are 2 readings, what are you supposed to do? You have to use the average. You have to use the average. Check whether the average is also away from the true value. So the revised definition for bias I am giving you now. If you are taking multiple reading, the revised definition for bias is the difference between the average of the readings and the true value. What is the definition for bias now? Difference between the average of the readings or average of the measured values and the true value. Clear, all of you? It's not that much difficult. All of you are with me on this?
Yes.
First, perform the check for the consistency. Ensure gauge order is less than 10%. Then perform this study, bias study, and then try to understand whether you have a bias or not. If there is a bias, try to understand whether the bias is positive or negative. Since you have consistency in your reading, your bias can now be stable. Since you have consistency, your bias can now be stable. There is a biggest advantage if you have a stable bias. Always, if you have a positive bias of 2 minutes, there is an advantage. Imagine you have a watch which is very old. The problem with the watch is it always runs 5 minutes faster. Can you still use the watch? Tell me, will
Yes,
you
we
be
can
able to
do.
use the
Yeah,
watch
yes. Yes.
Yeah,
to
we
find
can
out
do.
the true time?
Just to decrease 5 minutes.
That's all. This is known as data calibration. Instead of calibrating the data, instead of calibrating the instrument, you calibrate the data. That's all. This advantage is possible only if you have a stable bias, constant bias. Clear, all of you? Hereafter, if you are facing the issue of a constant bias, don't worry. Ask your people to collect the data. If there is a positive bias, you subtract it from all the data. Your data will be accurate. Clear, all of you? If there is a positive bias and if that is constant, subtract that value from all the reading. Now the subtracted value will be very accurate. You are able to eliminate the bias. Suppose if the bias is negative, what are you supposed to do? You have to add the bias. If you have a negative bias, let's say your watch is running 5 minutes slower. It is showing 8:55. That means what is the correct time now? 9 o'clock.
9 o'clock.
So you have to add the negative bias to your measured value to make your readings accurate. Very simple logic. All of you, can you understand? And suppose you don't like this bias. You want your watch to always give the accurate value. What will you do? You will adjust your watch itself. Yes or no? That is called calibration. That is called instrument calibration. But then and there adjusting your watch, if that is not serving the purpose, what will you do? You take your watch to the nearest service center. Yes or no?
Yes.
And what that fellow will do? That fellow will check the battery condition and throw away the old battery, put the new battery and check the lubrications and any parts worn out, small parts, anything worn out, he will replace. Now, even though your watch is old, when it is calibrated, it will start giving you bias-free reading. Yes or no?
Yes.
So, bias in the instrument can be eliminated by calibrating the instrument. But please note, over and above, maintenance of the measuring instrument is very, very important. Otherwise, it will quickly go out of condition again. If it is a watch, you are supposed to handle it, carefully. You can't simply throw it everywhere on the table, onto the floor. No, you have to use it carefully. And you should also know how to use the measuring instrument, how to store the measuring instrument. Certain instrument have to be kept in the air-conditioned room. All that have to be understood and that must be maintained. Otherwise, bias will populate. Now, one more problem can come. After calibration, your watch runs in an error-free manner for 3 months. After that, again the problem started. Now, what will you do? You will again go to the service center. Again, you will calibrate. Now you are gaining a new knowledge. What is that knowledge? Your watch needs attention once in 3 months. This is known as calibration frequency. If you are dealing with measurement system, you must know all this information. Right? The calibration frequency should be known, calibration procedure, isn't it? And then if at all there is, if it is a bias free, then when the possibility of bias is only from the consistency point of view. And that also you know how to tackle it, isn't it? To bring it below 10%. Train your people very frequently and then give them proper instruction and maintain the instrument in a proper room and everything. If you take care, the error due to inconsistency will be below 10%. So the maximum bias that can happen is limited to 10% by using a properly calibrated measuring instrument. All of you are clear? Now the amount of risk that lies with your data, particularly due to the measurement, is limited to 10%. Is limited to 10%. And moreover, if your process is running well inside the specification, that 10% cannot affect your decisions. If your process is operating comfortably inside the spec, then the 10% error will not lead to any wrong decision. Always a good product will be classified as good, bad product will be classified as bad. But if your process is weaker means what? Your process operate to the specification, which is not a good sign. I'll show how this will look like. Customer has given upper spec, lower spec, and your process is operating like this. Can you see that? Your process has got a control limit here, upper control limit, lower control limit. Always the distance between upper control limit and lower control limit will be equal to 6 sigma, Now, what is the situation? Your process consumes all the tolerance given by the customer. Am I right?
Yes.
Your process is operating in a way that it operates everywhere in the tolerance.
Yes.
In this scenario, 10 to 30% condition and all unacceptable.
So it is consuming 100% of the tolerance, right, sir?
Yeah, in this scenario, 10 to 30% is not applicable. Many people dealing with the gauge R&R, they think that no, it is conditionally acceptable. Conditionally acceptable, they think that if the equipment is costlier, you can accept. Illogical, decision. The conditionally acceptable scenario, how do you handle? By knowing the capability of the process. Clear? And now this process in a very bad shape. Now 10 to 30% condition is not at all acceptable. Suppose if you are working in a process, in this manner, let's say your process is operating like this. Can you see your process now?
Yes.
Your process is coming only up to this point. For this process, even if you have a measurement system of 30% error, still it is acceptable.
Yes.
Do you understand? If you have a very wider tolerance, 10 to 30% is applicable. If you have a very, very narrower tolerance with respect to the spread of the process, then, don't use the second condition, 10 to 30%. Hope all of you understand what I'm trying to say.
Sir, if the
All right.
CpCpK should be means less than 2, Then
This
also we cannot do.
process will certainly have a CpK of more than 1.67.
Yes.
Whereas this process has a CpK of less than or equal to 1. Right? So
Right.
actually, strictly speaking, now the CpK in this case is 2. CpK in
Yes.
this case is 2, but in the long run, that will reduce to 1.67. That is the point. That is why we say 1.67. Even though it is 2, in the long run, that will have a chance to reduce to 1.67. See, it is very simple process capability. You might have discussed yesterday CpCpK. I will definitely come there. Actually, I was thinking about talking about the hypothesis testing, but I am not going to do it today because I think you must definitely strengthen your understanding on the define and measure. Then definitely we still have some next week complete time to talk about hypothesis testing and others. So we will go to the CpCpK also. So now the measurement system analysis is understood. You perform gauge order study, then check the bias, then do the calibration. Now everything is perfect. Now you proceed with the data collection. Data collection, always the challenge is sample size. Yes or no?
Yes.
People always ask questions, sir, how much sample I should take? I want to take 30 sample. I want to take 40 sample. Whether 60 sample will do, 90 sample will do. Take my, guidelines. First, before talking about the sample size, judge correctly the data collection period. First, you judge correctly the duration of data collection. You want to collect the data for 1 week or 1 month or 15 days. Will you be able to make a decision, right decision? Let's say you want to understand whether you are diabetic or not. Now, how many weeks you need to take your blood sample to confirm this?
3-month average.
Oh, 3 months average. Okay. I think 1 week continuously, or 3 days continuously, if you take a reading, you will know your sugar level. Yes or no?
Average.
So logically, you take a decision. This is known as data collection period. Clear, all of you? It can be 1 week sometimes. It can be 1 month sometimes. It can be 2 weeks. It can be just 1 day. The situation will decide. Yes or no?
Yes.
If a client suddenly informs, I will be coming in 3 days, you prepare a CpCpK report. Now you only have 3 days. Now within the 3 days, you have to collect. So data collection period can be decided logically, understanding the condition. After that, data collection frequency. Data collection frequency. 1 week is the data collection period. Now there are 7 days. And every day you have 3 shifts. Yes or no? Now you have to ask yourself, do you have to collect data from every shift? Yes or no?
Yes.
We have to collect data from every shift.
Yes, sir.
Yes.
So every shift we have to collect sample, and every day also we have to collect sample. And now in a shift you have 8 hours.
Yes.
Now ask yourself, do you want to collect data every single hour, or just once in a shift, or twice in a shift, or thrice in a shift? Will you be able to answer yourself?
Price initiative.
Which is better? Always better, no, more is better. How much
Yes.
money you want? I want more money. Always more is better, but situation, will not allow. So I have seen companies collecting sample once in 15 minutes. Yes or no? Some companies, particularly food industries, isn't it? If something goes wrong, rework is not possible. Yes or no? Something goes wrong, you are producing a food item and then salt is not added. Now all the units produced has to be rejected. So they can't afford, if you keep the samples, at what to say, the sample frequency, very low frequency, isn't it? Suppose you take once in 4 hours, all the production of 4 hours, should be scrapped. Company cannot afford, yes or no? So you have to increase the sample collection frequency to monitor anything. So decide wisely on the sample collection frequency. If you decide on the sample collection period and decide on the sample collection frequency, now your sample size can be restricted to any number between 2 and 25. Can be restricted to any number between 2 and 25. Better avoid taking one sample. Better avoid taking one sample. That too in a rare condition you may have to take. Suppose if the sample is too costly, you can't avoid. One sample is 20,000 rupees. Now, no, company will not allow. Right? The advantage of taking multiple sample, you know what is the advantage? You can calculate average and then try to understand what is happening. Yes or no? Because the average has more tendency to follow your bell curve than a individual data following bell curve. Your average have more tendency to follow the bell curve. The only factor that decides the formation of bell curve is your sample size. The only factor that decides the formation of bell curve is your sample size. This is known as central limit theorem. If 2 is not really getting you the bell curve, try with the 3. If 3 is not getting, try with the 5. I'm sure, when you come closer, definitely less than 10, this will happen. You will be able to judge very properly and keep this as a standard way of sample collection. Once you understand, yes, this much data is enough, then all good. And then suppose, let's say your sample size is 10. If your sample size is 10, you should take all the 10 samples at the same time. Please note, you should not leave any gap between them. Do you get my point? If your sample size is 10, all the 10 sample, if you go to 9 o'clock, 9 o'clock itself, you have to take all 10 samples. Right? This must be followed. Because all these samples must be collected as a single group. Right? And within a shorter time, you must take 10 samples. If you follow all these things, then the bell curve will be smooth, and then all the normal distribution knowledge you gained can be applied. What do you know about normal distribution? Please tell me, all of you, before going to the central limit there. Before going to the CpCpK. Now data collection plan is ready. Measurement system is validated. And now you actually collect the data and use the data to calculate your first pass yield, to calculate your DPMO, or calculate your PPM, or calculate your CpCpK, depending on the data type. If your data is a continuous data, CpCpK is the apt one. If data is continuous, you must go for CpCpK. If data is not continuous, it is discrete. That's the time you go for your DPMO. That's the time you go for your PPM. That's the time you go for your yield. All right. Now, yield, there are different types of yield. You all know what is the formula for yield? Output divided by input. Right? Or units rejected against units produced. This is the yield formula. Yes or no? Units rejected, yes. Your output divided by input, right? Say for example, you produced 100 units and 95 units are accepted. 5 units are rejected. Now, how many acceptable units you have? 95. How many units you produced? 100. Now, the formula for calculating the yield is accepted outputs divided by produced units. Now, tell me, how many are accepted? 95. How many you produced? 100. So, your yield is 95%. This is one way of measuring your baseline. How do we call it? Yield. This is how traditionally many companies calculate. Hope all of you are using this. Am I right?
Yes, sir.
Most of you are using this. But I want to ask all of you one more question. You are telling that your yield is 95%. Tell me how many units you have produced in an acceptable manner without doing any rework.
95, sir.
95.
Have you produced all 95 without any piece of rework?
No.
Some rework happened, isn't it?
Yes.
First
Though
time,
it is
right?
difficult. Though it is difficult to bring that explanation to the surface, you have to bring it. If you are seeking improvement, you must be open enough, right? And now you come forward and tell me that, sir, 20 units out of the 95 were rework. So without doing rework, how many units you produced in an acceptable manner? Already 5 gone, now 20 gone. So how many
75.
units are produced with
75.
properly without rework?
75.
75.
75.
So 75% is your actual yield. This is the
First
real
pass yield.
capability of your process. This is the real capability of your process. This is known as first pass yield. Please don't cheat yourself by looking at the traditional yield. You must look at the first pass yield. Then only you understand the real capability of your process. Otherwise, you are unnecessarily, you are giving, a wrong direction to yourself. How many of you would like to pass the exam in the first attempt itself?
Yes, sir.
Everyone.
Everyone. That
Everyone.
means you want the first pass yield, isn't it? But in workplace, you don't want to respect that principle. Workplace also, we need the first pass yield, right? So ask for the first pass yield, look for the first pass yield, and using the right tools will increase, your improvement opportunities. All the problems will come to the surface. Everything will become, visible and obvious. Otherwise, problem will be hidden. Yes or no? Otherwise,
Yes.
problem will be hidden. People always say everything, sir, everything is good. But what is your profit margin? Profit margin is less. Clear? So the best measure is first pass yield. Now moving on to the other tool. What is the other tool? DPMO. You all know how to measure DPMO. Is that calculation understood? DPMO, all of you? All of you, do you know how to calculate DPMO? Please tell me if yes or no.
Yes, sir. The total number of defective parts divided by how many parts we have produced into 1 million.
Not defective parts. If you say defective, then you are going to PPM.
Part per
Defective should
million.
not be used. You must count the defects. Defects are different. Defectives are different, isn't it? Defectives is a term applicable to the complete part getting rejected. Defect is applicable to the mistake you did in a particular product. The non-conformances that is present in a product. There can be one or more number of defect in the same product. Clear, all of you? Yes or no?
Yes, sir.
Any of you, do you have the Gems chocolate with you right now? You have been advised to buy one chocolate. I don't know how many of you purchased and you are retaining it so long. Don't have, right? Okay, no problem. So the thing is, you should be able to detect the defects and record it. If you could detect the defects and record it, then what will happen? You will be able to calculate DPMO. Don't worry, today I did the same exercise with another batch. I will show you that, right? So we don't have to do the same exercise again. We can also save a time on that. See here, GEMS exercise. There are how many people? See here, 7 people participated because 7 people only brought the GEMS chocolate. You see, 6 only. Satish, Surender, Prasad, Vikram, Dalijit, and Navra, Ilavarsan, and Nasir. 7 people. And each person purchased a GEMS pack which contained 10 pieces, which is expected to have 10 pieces. In order to check for the quality, the CTQs must be understood. Yes or no? Otherwise, what to check, people will not know. Now, in a GEMS chocolate, the CTQs are defined. Every pack of GEMS is expected to have 10 pieces. All of you understand first requirement? 10 pieces. Second requirement, color. It can have different colors, but color should not be faded. Color should not mix up with other color. If those things are observed, that is classified as defect number 2. All of you understand defect number 2? This is defect number 1, D1, and this is defect number 2. Third defect is crack. You all know what is a cracked gem, isn't it? If the gem is broken or if there is a sign of crack, that is called crack. How many gems had the crack? The fourth defect is shape. The expected shape is circular and round. If the chocolate is elliptical or if it has a sharp corner, that particular gems is considered a defect, right? Is considered to have a defect, fourth defect. And finally, the test. Test means you know the consumer's opinion. And now every pack is opened. These 7 people have checked for the defects. See here, first person, what is his name? Satish. He had only 9 pieces. That means how many gems are missing?
1 gems.
So that is recorded as a defect. You see here, 1. For some people, it is exactly 10. And for some others, no, 1 piece was found to be missing. So that is recorded. All right. Similarly,
Sir,
color. Yes.
sir, in yesterday class, sir told that every defect should be measurable, right?
Yeah.
So color and shape, how is measurable at that time when?
Yeah. See, measure, if the defects are made measurable, that gives a great scenario.
Okay.
You go with the continuous data. But certain situations, you can't go with the continuous data. That's why, you know, we have another type of data known as attribute or discrete data. This exercise is for the discrete data.
Okay. Right.
There are a lot of visual inspection you are doing in your workplace, yes or no?
Yes.
Sir,
All the
can
visual
we
inspection, no?
excuse me,
Good
sir?
yes.
Can we say that it is qualitative data?
Yeah, correct.
Attribute
Qualitative data.
and qualitative is same.
Qualitative data, attribute data, discrete data, no, it's same. But
Yes.
qualitative data, we converted into a discrete format.
Yes.
We converted into discrete data. Basically, qualitative means non-numbers. No numbers.
Temperature,
Yeah, it is
color.
written in the form of non-number format. But there is a way to convert that into number format. If you convert that into number format, it is known as discrete. Like for example, how is our training? You will say excellent. Then excellent, we will ask you to put 5. Isn't it?
Yes.
Yes.
So finally, it has come to number form. So people have marked so many numbers you could understand. And finally, all the 7 people, they reported total of 30 defects. Can you see that? How many reports are defected? 30. But how many samples they have checked?
65.
How many? 65 samples. 65 samples are checked. 30 defects are recorded. So let us go down and do the max. I'm only trying to educate you on this, nothing else. Templates are available. Units inspected, I am typing as 65, right? And then defects reported 30. Now, opportunities per gem. How many defect opportunities we defined?
5.
So 5 is written. And then total opportunities. If there are 65 samples, in each sample, 5 defects can occur. So what is the total opportunity for defect? 65 into 5?
325.
325. Total opportunity is known and then total defect is also known. Now I want you to calculate something known as DPO. Formula, the question itself has the answer. What is DPO? Defects divided by total opportunity. So defect is how much? 30. What is total opportunity? 325. Now what is the answer you are getting? 0.09. 0.09 is DPO. What do we want to know? DPMO. The formula is you multiply by 1 million. Please note, if the cost of one apple is 1 rupee, what will be the cost of 1 million apples?
10 lakhs. Sorry.
Not 10 lakhs.
Sorry, sorry.
One apple, I said 1 rupee.
Okay.
So 1 million apple will be
1 million.
1 million rupee. You just have to multiply. Here, one apple is 1 DPO. One apple is 1 DPO. I want to convert the DPO into DPMO. All that I need to do is just take this value and multiply by 10 to the power of 6. All right. So what is the DPMO now? 92,307. This can now be converted into sigma level. We have templates, right? So DPMO calculation is understood. Please remember 92,307. Come here to this particular second sheet, sigma level calculator. Here, you type your 92,307. 92,307. When you type 92,307, what is the sigma level you see here?
2.83.
2.83. So you have to improve your process so that the DPMO should go down. Suppose if you really improve the process, DPMO becomes 9,000 from 90,000. Can you see the improvement in the sigma level?
Yes.
Sigma level is going up. Suppose you further improve the process, the 9,000 becomes 900. What is the sigma level now?
4.62.
And you further improve, it is now 5.25. You further improve, it is 9. Now it is 5.79. If I type 3.4 here, what is the sigma level?
6.
This is the benchmark performance set by Motorola. If you elevate any process to a 6 sigma capability, it will produce defects fewer than 3.4. Only 3 or 4 defects only will happen if you operate any process at a 6 sigma capability. If you operate any process at a 6 sigma capability, it will have a tendency to produce only 3 or 4 defects out of 1 million. Very, very rare chance of producing a defect in your product. Practically customer cannot receive a defective item. But theoretically, 3 or 4 defects are possible. All of you understand the advantage of running your process at a 6 sigma capability. Now let us understand what is 6 sigma capability in terms of CpCpK. You all have studied CpCpK, right?
Yes, sir.
So now DPMO is understood, yield is understood, CpCpK also you have already studied. We are going to recollect it. How are they called? First of all, CpCpK, what is the name of them? They are known as
Process capability.
process capability indices. There are 2 indices. One is CP, another one is CpK. CP, the specific name for CP is potential process capability ratio. The specific name for CP is potential process capability ratio. The other one is CpK. This is known as process capability index. Out of the 2, which can give a better estimate of the capability? CP can give or CpK? Any idea? Which is better?
CpK.
Which one we should use out of the 2?
CpK is the best.
CpK is better. Because there is a limitation, there is a problem with CP. I'll help you understand this with a very, very simple example. Imagine you have a road. Listen to me very carefully. You have a road. The road will have a size. And you have a car. You have a car. Now to have a safe drive and reach the destination, your car should be smaller than the road. Yes or no?
Yes.
If you have a car bigger than the road, your car actually cannot enter. If you still try to drive, what will happen? You have to scratch your car. Yes or no?
Yes.
Similarly, customer has given a tolerance. That is the road available. You have to drive your process inside that road only. If you don't understand this logic and rather you develop the process which is wider than the tolerance, what will happen to your process? your process will get scratched. If you produced 1,000, half of them, will undergo the scratch. They will lead to rejection. It is like having a car bigger than the parking area in your house. How many of you will do this mistake? You never do that mistake, right? While buying a car, you will be extremely careful. You know what is the parking area, and you will definitely buy the car smaller than the parking area. Tell me, if you have a 10 feet width in your parking area, if you have 10 feet width in your car parking area, what will be the width of the car? What will be the width? You will go for your car. Will you go for up to 10 feet car in
8.
the width?
No, 8.
7,
That
sir.
is why, your capability indexes should at least be more than 1. At least be more than 1. Suppose if your car size is half the size of the parking area, it gives a great scenario, isn't it? Very, very great scenario. You can effortlessly park your car, take it in the reverse, move it in the forward. Accident and scratching of the car will never happen. Agreed?
Yes.
Yes, sir.
But for 10 feet car parking area, if you purchased a 9 feet car, sometimes you may damage your own car. Yes or no? Because
Yes.
you are not in a good mood. You are parking your car and suddenly your wife is, calling you inside, and then, you will lose the control, and then your car will be, under trouble. So the same thing is possible in your business also. Your process spread, you have a method to know the size of your process. How many of you now learned the method to measure the size of the process? If you want to measure the size of the car, it is very simple, right? You take an inch tape and measure between the side mirror. That is the width of the car. Now, how will you measure the width of the process? Have you learned anything so far? Tell me, all of you.
Process
How
width
will
is
you?
6 sigma, no, sir.
6
We
Aha,
will
sigma.
minus
that's all.
the self.
Very simple. For everything, answer is 6 sigma. That's all. Any process, if it operates, right, and it will go up to certain extreme. That extreme is known as upper control limit. It will also go up to some extreme on the left side. And the distance between the extreme is, sometimes if you want to call it maximum and minimum. What is the difference between maximum and minimum? Range. The difference between maximum and minimum is range. Range is one way you can measure the spread of the process or width of the process. But it is not the right method always. Because for calculating the range, you only pick up the extreme values. Yes or no?
Yes.
You only take the maximum and minimum, but there are 100 data, but you are using only 2 data points. So that's why it is not recommended. The best way to measure the spread of the process is, you measure this 6 times sigma. 6 times sigma. So what is sigma? Standard deviation. This is the formula. You all have studied in 7th standard. I am again bringing it to your notice. Sigma equal to summation of x minus x bar the whole square divided by n minus 1. Where what is x bar? Sample average.
Mean.
X bar is sample average or process average?
Mean.
Mean. Very good. And n is sample size. X bar is process mean or process average, and n is sample size. We are actually trying to understand how far each of our product is with respect to the mean value. Mean is here. Mean is here, right? And you produced several parts. So many parts. You see here, so many you produced. If all of them are close to the center, then sigma will be minimum. Yes or no?
Yes.
If your process is stretching outward too much, and if the parts are moving away from the center, then sigma will be higher. Sigma if you allow the sigma to increase, that confirms that you poorly control your process. When you poorly control your process, then only the parts will move away from the target. Yes or no? So the value of the sigma is a direct indication of the amount of control you maintain in your process. If sigma is more, what does it mean? You have poor control. If sigma is less, you have better control. Clear, all of you? If sigma is
Sir, more
less,
means and
poor
less
control.
means.
If sigma is more, you have poor control over the process.
No, sir. More in the sense of means to compare with which value?
No. Just to look at the sigma and value. Standard deviation can be 2, standard deviation can be 2.5, standard deviation can be 3. See, if you design a process, originally it will behave very nicely. Yes or no? Starting time.
Yes.
That time you not only record the average, also record the standard deviation hereafter.
Sir, can we say 2 sigma is better than 3 sigma?
No, not like that. See, sigma means standard deviation. Sigma means standard deviation.
Standard deviation.
You calculate standard deviation separately. Then you are calculating the sigma level for the process. Sigma level is different, sigma is different. Sigma means standard deviation. But when I say sigma level, I am talking about process capability. My capability should be higher. If you want your capability to be higher, then the spread of your process should be minimal. If you want the spread to be minimal, then your sigma, the standard deviation of your process, should be a smaller value. If standard deviation is small, spread will be small. As a result, the process capability in terms of sigma level will be higher. Okay. So I'll go to the
Sir,
simple
one more
example.
question, sir. I have a
Please.
doubt.
Yeah.
Can we judge by seeing the bell curve that the data collection was not good, or is there any technique or any method, sir?
See, let me collect all your height. I'm measuring all your height. Yes, sir. Do you understand? I want all of you to give me your height data. Do you think all of you will have the same height?
No.
No. There will be variation. You people represent the Indian population. Yes or no?
Yes.
After recording all your height, I calculate the average out of it. What do you think will be the average? Because we all know about the characteristics of the people in India. People like all of you, what will be the average height?
5.5 maybe.
5.5
You are
or
correctly
5.
judging. Suppose if I conduct the training program in some other place, if the average height is only 4 feet, what do you understand now? The training is not happening in India.
Yes.
The training is probably happening in Japan or China. Yes or no?
Yes.
Yes.
So there is a clear difference in the average. It tells me whether my population is same or different. So that is that is the advantage of knowing about your population average. All of you should know your population average. When you design a process, you design it in the best manner. That time there will be an average. Yes or no?
Yes, sir.
You should never move away from that good average. Whatever is the good average, you must stick to it. That good average is nothing but the target given by the customer. Yes or no?
Yes.
Yes, sir.
Your average should never move away from the target, number one. Number two, I calculate after recording all your height data, I calculate a standard deviation out of it. If my data is in terms of feet, my standard deviation will approximately work out to be 1/4 of a feet. 1/4 of a feet. 1/4 means 0.25 feet. Now, once I know the average and the standard deviation. So what is the standard deviation I told you now?
0.25.
0.25. Now I want the participant here who have a height more than 6.25 feet. Is there anybody here? Is there any participant who have a height of more than 6.25?
I think nobody, sir.
Almost nil. This is what will happen if you add 3 standard deviation to your average with respect to any data. Do you understand? If you add 3 standard deviation, the chance of your data appearing outside the 3 standard deviation point, which we call it as control limit, will be very, very minimal, rare. See, no participant is here. I have not picked all of you. You randomly came, but none of you are above 6.25. I also want to know whether any participant is having a height below 4.75 feet. Maybe 1 or 2 possible. Please note, I'm not saying that it will never happen. 1 or 2 possible. Your population is spread in that manner. But if I ask you, how many of you are having a height between 5.25 and 5.75? If I ask you to come on video, many of you will come on video, yes or no?
Yes, sir.
Yes,
Because
sir.
now I have selected a range closer to the average. Can you see that? 5.25 to 5.75. 5.5 is the average. What is 5.25? 1 standard deviation to the left of center. Yes or no?
Yes,
What
sir.
is 5.75? 1 standard deviation to the right. Always you should know to what distance you are moving away from the center in terms of standard deviation. You should be comfortable in talking in terms of number of standard deviation. All of you understand what I'm speaking?
Yes,
If
sir.
you
Yes,
want
sir.
to be in a global market, if you are comfortable talking only in terms of rupees and not in terms of dollars, other person cannot deal with you. Yes or no?
Yes,
Yes,
sir.
sir.
If you want to talk to other people, people from other country, you must express in terms of dollars, not just in terms of rupees. Rupees is a local language, but the global language is what?
Dollar.
Dollar.
Dollars. Same manner, your problem locally can be in any number, any metric. You standardize your problem, standardize your data. If I standardize my data, it will be in terms of average, in terms of standard deviation. Do you understand?
Yes, sir.
If you move away too much, if you move far away from the average, that is not good. Those products will become bad. Yes or no?
Yes, sir.
Yes.
So you should always know how much distance you are moving away from the center, that too in terms of number of standard deviation. Now tell me, I will draw the same scenario. See here, there is a population. There is a population. Now my data is representing all your height. You confirmed me that the average height is 5.5 feet, right?
Yes.
And X bar is 5.5 and standard deviation is 0.25. Now I am moving away by a distance equal to 1 standard deviation. 1 standard deviation means what will be this point?
5.2,
7.5.
5.75.
You can always say the distance is 0.25.
Yes.
You can always say the distance is 1s. Both are correct.
Yes,
Yes,
sir.
sir.
Yes.
Now you are becoming a statistician. That's all. And similarly, this side is 5.25. What will be the distance here in terms of standard deviation?
0.25 and minus 1 is
0.25.
See, my question distance. When I ask you the question, it is 0.25. When I ask you in terms of standard deviation, it is 1 standard
One
deviation.
thing.
1 standard deviation.
1 standard. That is very important. If you move away from the center by 1 standard deviation, now how many data points will be inside your 1 standard deviation? 68%.
68%.
You remember I told you, all of you come on
Yes.
video, those who are having a height between 5.25 and 5.75, you will be surprised to see close to 70% of the participant coming on video. Yes or no? This
Yes.
will happen with any continuous data. Any process that is running naturally and data, if the data is measured in the continuous manner, I mean continuous data, it will definitely exhibit normality. All that required is the sufficient amount of data. And here right now there are 30 participants. I can definitely prove with the 35 participants, the bell curve coming. We should only have the time to record the data and then, plot it in a graph. Then we will certainly get the, bell curve. You already confirmed there is no one beyond 6.25. You know why there is no one beyond 6.25? Now tell me what is the distance of 6.25 from the center? 0.75. Am I right?
0.75. Yes.
Can
Yes,
you
sir.
express the same thing in terms of standard deviation? How many standard deviation?
3.
3 sigma.
If you move away from the center by 3 times standard deviation, probably that will be the maximum value in your data. Very, very rarely you see 1 or 2 points beyond the control limit. That is why in control limit, if anything falls in control chart, anything falls outside the control limit, we immediately question the team. Hey, why is it falling outside? The chances are minimal. Can you see that?
Yes.
Similarly, the same thing on the left side. These points are known as lower control limit. Lower control limit, and this side is upper control limit. Why it is not writing properly? Okay. If you consider upper control limit and lower control limit, almost the entire population is covered. Can you see that? Almost the
Yes.
entire population is
Yes,
covered.
sir.
In
Yes.
terms of percentage, it will work out to 99.73.
Yes.
It will work out to 99 points. This is the property of normal distribution. Please note, all of you. Here, after anybody talks about normal distribution, don't look at him as a stranger. Because you are also now familiar with normal distribution. It is a bell curve. It is symmetrical at the center. Symmetrical means draw a line. Whatever you see on the right side, the same shape you see on the left side also. All right?
Yes.
Now, when you draw a line at the center, which is the average, that will divide your population into exactly 2 half. Can you say that?
Yes.
50% on the right side, 50% on the left side. If you move away from the center by 1 standard deviation on the right as well as on the left, what percentage of the data will now be included?
68%.
68.27. Remember the number, 68.27. It is also applicable to population. If you take the sample in the right manner, whatever you see in the sample, the same thing will happen in the population also. Yes or no? If you know how to collect the samples correctly, whatever you see in the sample, the same thing will appear in the will appear in the population also. Or otherwise, whatever your the characteristics of the population, that will appear in the sample also. What is required to be controlled is, collect the samples without committing error. That is why I spoke about the error. You should not make any error while collecting the data, isn't it? Error of 2 types. One is measurement error, another one is sampling error. You must consciously control both so that whatever predictions you make using the sample can be very correct. So 68 to 68.27% of your data are expected to be inside your 1 sigma limit. 95.45% of your data are expected to be inside 2 sigma limit.
Yes.
99.73% of your data are expected to be inside your 3 sigma limit. 3 sigma limits are given a special name, control limits. 3 sigma limits are given a special name known as control limits. So what percentage of the points will fall under control limit?
99.37.
That means if your sample is really good, if your sample data is really good, you can expect 99.73% of your population to lie inside control limit. Clear?
Yes.
If you have a quality sample in your hand and calculate a control limit, you can boldly say, sir, my process will produce parts only inside the control limit, because there is 99.73% chances there, which is a very high percentage. Yes or no?
So what is the percentage of 2 sigma, sir? 95 point?
95.45 is applicable to 2 sigma.
2 sigma.
Okay.
99.73 is applicable to 3 sigma. Please note, statistics is based on experimental evidence. Statistics is based on experimental evidence. You go to any place, meet 1,000 people, record all their height. You randomly meet 1,000 people, record all their height. Do you get my point? And calculate the average. Calculate the standard deviation. See, check for yourself whether all these properties are no getting fulfilled or not. What is the sample size I recommended? 1,000, right?
Yes.
1,000 is quite a bigger sample size. Definitely you will see all the properties getting fulfilled. Even a random sample of 1,000 will fulfill this property, right? So,
Yes.
but if you know the sampling technique, even with 100 samples, you can see the properties happening. With the high quality samples, even with the 30 samples, you can expect the properties. All right, good. Now let us go back to our simple example. You parking your car in the parking area. Imagine your parking area is 6 feet, your car is also 6 feet. Now, can you park very conveniently?
No.
No, sir.
No, sir.
Not, sir.
From outside, it looks okay. But when you actually drive, your side mirror is not touching the wall. Your side mirror is nothing but the control limit. The side mirror is nothing but the control limit. Right side, there is a side mirror. Left side also, there is a side mirror. The right side mirror name is upper control limit. The left one is
Lower
lower
control
limit.
limit.
Can you drive a car making the side mirrors touching the wall?
No, sir.
No. Don't allow your control limits to touch the specification limit. All of you understand?
Yes.
Please tell me, specification limits are known to you?
Yes.
Yes, sir.
Can you also find out your control limits from the process?
Yes, sir.
How? Collect sample,
Yes, sir.
calculate average, calculate standard deviation, then add 3 standard deviation to the average. That will result in control limit. Yes or no?
Yes, sir.
Yes.
There is a way to find out your control limit. Now you compare where is the control limit, where is the specification limit. If your control limit is touching the specification limit, what do you understand? You purchased a car equal to the size of the parking area. You made a mistake. Yes or no?
Yes, sir.
Your team has developed a process which is occupying the complete tolerance. Yes or no?
Yes.
Your team do not know how to develop a process. They made a mistake. The design itself, there is a mistake. Can you see that? If you purchase a car in that manner, but your decision itself is wrong. You have to suffer throughout the life. Yes or no? So how the
Yes, sir.
process is designed, what is the nature of the process with respect to the tolerance, you can very well understand if you know your control limit. This scenario is known as just capable scenario. This scenario is known as just capable. In this situation, your Cp and Cpk will be equal to 1. In this very worst situation, yes or no? Your car,
Yes, sir.
your side mirrors always, touching the walls. This is known as Cp equal to Cpk equal to 1. You very well know this situation will not, hold good. So you will definitely change your car. You will definitely change your car, isn't it? Now, if you buy a car which is half the size of the parking area, half the size of the parking area, now what will happen? You are consuming only half of the tolerance. Now since your car has reduced, your capability will double now. Since you are consuming only half of the tolerance, you now have doubly capable scenario. Doubly capable scenario means your Cp and Cpk both are equal to 2. Both are equal to 2. Now you are parking a car. Suddenly you are receiving a call from your boss. You lift your call. At the same time you are parking your car. Still your parking is safe. You know why? You had an additional tolerance, additional cushion on both sides. Can you see that?
Yes, sir.
Even if you make some small mistake, due to, some kind of emergency, still it is not going to the extent of scratching your car. Similarly, your business process also will have a tendency to, slightly move left or right. But still, even if it moves to the left, moves to the right, then also the outputs will not get rejected. All of you understand? So
Yes,
you
sir.
can
CP
make the
CP will be
process.
2 and CPK maybe 1.67. Like,
I'll come to that. Both your CPs in ideal condition, both CP and CPK should be equal. Please note, all of you. What is ideal condition? Whenever you park the car, you always park the car at the center of the parking area. Yes or no?
yes.
Yes.
People who know the driving, they always park the car at the center. Suppose you don't have a proper driving skill. What will you do? You will have a tendency to drift to the left side, or you will have a tendency to drift to the right side. Yes or no?
Yes,
Yes.
sir.
Yes, sir.
So that will also appear in your data. Your process, whether your process is center means the target. If your process is at the center, if your process is at the target, exactly at the target, it means it is centered properly. If your process moving to the left, you can see the average moving away from the customer target. Yes or no?
Yes.
Yes.
Similarly, if your process has a tendency to move to the right, you will see your average moving to the right of the target. If the process is moving to right, if the process average is moving to the right or left, you have a problem with driving the car. Car is good, please note. Car is good, but you don't know how to drive it. There is a problem with the driving skill. You need to find out what mistake your people are doing. Try to shift your process, bring it to the target area. This is called shifting of the process. Process can shift to either side, left side or right side. If people know how to drive, because there is an SOP available, you follow the SOP, do as per the instruction. If you follow it, process will be always centered properly on the target. Only problem is the spread of the process. If that also taken care during the design, your process will never produce defects. What is required is a doubly capable scenario. A doubly capable scenario at the same time, CP must always remain equal to CPK. If CP remains equal to CPK, that means you are not drifting to the left, you are not drifting to the right, you are driving properly. Whenever you see CpCpK different, please understand there is a problem with the driving. Please understand your process is shifting to either side, left or right. Some attention is required. Attention is required, and then you find out the reason and fix it. So CpCpK equal to 2 means the capability is Six Sigma capability. So there is a way to convert your CpCpK into Sigma level. Now the secret is understood. CPK 2, how the 2 can become 6? Tell me. How can you make the 2 to become 6? Come on.
Multiply by 3.
That's all. That is the secret. That is the formula. If your CPK is 2, your sigma level is 6. If your CPK becomes 3, what will be your sigma level? If CPK is 3, what will be the sigma level?
9.
9. Very simple. Also, please note, even though you have good driving skill, you purchased a good car, in the long run, slowly, you become old. You will have a tendency to slightly, move away from the target. So it is statistically expected that any process in a long run can move away from the target by a distance equal to 1.5 standard deviation. It is assumption. How much distance a process is expected to move away from the target? 1.5 standard deviation. If you design a process with a Six Sigma capability, in the long run, the capability will drop to 4.5. That is why CPK of 2 will come down to 1.6 honors. That is why the guideline is arrived. Expecting this, No, AAG has given a guideline. You at least maintain a CpK of 1.67. Clear? Always at any moment it should be at 1.67. The CpCpK is applicable for any process in which you measure the performance of the process using continuous data. That's all. Not only applicable to manufacturing industry. Many people misunderstand. CpCpK can be used only in manufacturing industry. You can use CpCpK in your industry, no matter whatever industry you are running, because what is required to be understood? The data type needs to be understood. All your test mark, what is the type of data? Your test mark? Test marks are considered continuous data. Test marks are wherever average is possible, that is actually continuous data. Wherever average is not possible, you go with the percentage. That means the data is discrete data. Clear, all of you? The moment you understand average is possible, the data is continuous, you can use CpCpK. One restaurant, hotel, food industry, one restaurant has used CpCpK effectively. One restaurant manager, he did a project. You know what was the project? The buffet lunch should be offered to the customer at a particular temperature range only. Am I right? Let's say you are the restaurant manager, it's a 5-star hotel. The customer requirement is food should be always, in a temperature, let us say 40 to 50 degrees Celsius. The sambar, the rice, whatever, everything should be at what temperature? 40 to 50 degrees Celsius. Now, what is the upper spec and lower spec here?
40 and 50.
45 is a lower spec.
Now, 40 to 50, I said. So, 40 is lower spec,
50
50
is
is
higher.
upper spec. So, target is how much? 45.
45.
Now, this restaurant manager of the 5-star hotel, he calculates CpCpK by collecting data for 1 week. 1 week every day, because he can't stand always, during the lunchtime. He has to do a lot of work. So he instructed his people to record the temperature of the food. Tell me if the lunch time is between 1 o'clock to 3 o'clock or 1 o'clock to 2 o'clock, let us say. Now, how will you advise your team to take a sample? Now tell me. Come on, tell me.
Measure the temperature, sir.
Measure the temperature.
Measuring temp-
But you have decided to, in order to know the capability, you decided to collect the data for 1 week. That's a good idea.
Sir.
1 week. And every day, 1 hour only. What is that hour? 1 p.m. to 2 p.m. Why that particular period is taken? Because that is the lunch time. Logical decision, isn't it?
Yes, sir.
And now within 1 to 2, what time you have to collect the sample?
130.
Exactly 1 o'clock you want to collect the sample? You very well know people will come from 1 o'clock and up to 2 o'clock. Yes or no?
Yes, sir.
If you really wanted to understand the experience of the people, you should spread your data collection from 1 p.m. to 2 p.m. Right? Between 1 to 2 p.m., suppose you decided to measure the temperature 10 times. At what time many people will be having the lunch?
1 o'clock.
What time?
1:30
When
to
will you have
2:30.
more people in your restaurant between 1 to 2?
30, sir.
130 and 130.
1:30 to
1:30,
2:30.
because 1:30 is the average time, isn't it?
Yes,
Yes.
sir.
1:30 is the center. Many people will be having the average around 1:30. If you decide to take 10 samples, take more number of samples around 1:30 p.m.
Between 1 to 130.
Yeah, maybe 5 or 6 samples between 1:30 plus or minus 10 minutes. What will be the majority of the customer experience? Your sample can catch perfectly. Yes or no?
Yes, sir.
And between from 1 o'clock to 1:20, fewer number of people will come for early lunch. Yes or no?
Yes.
Yes.
In order to capture them, you take 2 samples. And then 1:40 to 2 o'clock, last 20 minutes, you take another 2 samples. You imagine I am taking the sample, slightly similar to the bell curve. Have you noticed?
Yes, sir.
Yes.
That is how all process will behave. You need to know. Suppose you influence a process. Influencing a process means you bring 100 people, suddenly put all of them into the dining area. That is not a natural process. Yes or no?
Yes,
Like
sir.
I am conducting a training, I am suddenly announcing all of you lunch. Now there will be heavy rush. This is a rare cases. Yes or no?
Yes, sir.
But normally in a restaurant, do you think always somebody will bring 100 people for your restaurant?
No.
Natural way, your data will behave naturally and bell curve will definitely get formed. If you have a big habit of changing your process now and then, you may not get normality. Allow the process to perform on its own. Then you expect normality. Apply all your learnings about the normality. You will make beautiful decisions. Your company will love the way you are working. You need to know, first of all, whether your process is performing naturally or it is under the influence. If it is under the influence, too many changes, bell curve will not come. You should know that. That is why allow the process, allow the process to perform for a considerable period of time, collect the data over a considerable period of time, and then your data can speak better. Really, the restaurant manager, he calculated CpCpK and he concluded about his capability to satisfy the customer. He can satisfy the customer to a greater extent if he can maintain a higher CpK of more than 1.67. Yes or no?
Yes, sir.
Now hotel, can pay you very, a better salary, better incentive because you know how to control. You are not physically present there in that restaurant. You can see the restaurant manager physically present, doing everything. You can also see somebody, always sitting in the room, but still controlling everything perfectly with the help of data. Who will be paid better? One who is, taking the, rice box and then serving everyone at that lunchtime, or one who is, ensuring that, every customer is happy.
Ensuring, sir.
That's
Ensuring
all.
the manager.
That is what we want all of you to do. But then you need a quality data. You deserve a quality data. If your people are not cheating you by giving you poor quality data, then all your decision will go wrong. Initially, there will be some struggles, but then once you understand the logic and then create procedures on data collection also, everything will come in line, and you can make effective decision. You know when to make a change and when not to make a change. Clear? So this is what is expected from a measure phase. The correct baseline, the accurate baseline performance is understood. You correctly understand whether your process is under trouble or not. If it is under trouble, how much is the intensity of trouble? What is the gap in performance? You can correctly judge. Don't pray fall to measurement error and sampling error. People who don't know, who lag in terms of all this understanding, if you ask some data, they will prepare a brand new data for you. They will generate a data for you sitting at their home and then send you a handful of data and useless data. You cannot use that. How we want the data? We want the real natural data coming from the process when it is performing in the natural way, isn't it? Whatever way designed, it should perform in that manner. Just for the sake of data, you should not run the process. Am I right?
Yes, sir.
Yes.
Many people do that mistake also. Every time when they take the data, they alert everything. That is of no use. That will give a completely different picture. There is no use at all. You don't have to do any investigation in that manner. Data should be part and parcel of your life. You collect data in that manner, then only it will speak better. Clear?
Yes, sir.
Yes, sir. Sir,
I think this is
can you briefly explain on graphical CpCpK on graph?
on a
What is the
graph.
difference? Yeah.
Okay, I will try. I will try to do it quickly, right?
Yeah,
Sir,
so
I need,
quickly.
sir, I need one more spot from you.
One more?
Hello. One more spot, sir. One more suggestion from you, sir. In some
One more.
cases, sir, in
Ah.
some cases, LCL is defined, sir. For example, if we given the chips packet, okay. So we have decided we have to give minimum 50 gram chips. But
Okay,
how
okay.
the upper control limit, sir, in that case?
Okay, I'll come to your question, right? First, let me answer the other person question. There is an upper spec, there is a lower spec, right?
Yes, yes,
Now your process can operate in the center properly. Process is operating in the center properly. Exactly, it is operating on the target. Can you see that?
yes,
And upper control limit is here, lower control limit is here. Am I right?
yes,
Even after the control limit, you still have a cushion. That means if the process is slightly disturbed, moved to the right side, nothing serious will happen. You see here, let me show you how the process will look like. Can you see now?
yes,
This situation should be considered an internal failure. This situation should be considered an internal failure. Action is required or not?
Yes.
Tell me. Action is required or not?
Yes, sir.
Required.
required.
You have to pull this process back to the target.
Yes,
If you don't take this action, very soon your customer will experience failures. Yes or no?
yes,
People who do not react to the internal failure, they will suffer a lot with external failures. All right? If
yes,
you know what is the best place for your control limit, this is the best place for your control limit. Yes or no?
yes,
And if you see outputs going beyond the control limits, there itself you must take some action. That itself should be recognized as a failure. You should not say, no, it is still with the spec. No. I know it is still within the spec, but still it is something abnormal, unusual has happened. Can you see that?
yes,
So this awareness should be there. So this scenario, lower spec, upper spec, lower spec, process is center and it is here. And now this is the width of the process, right? And whereas this is the width of the specification. Width of the process is 6 sigma, but width of the specification is double the 6 sigma. That means 12 sigma. Can you see that?
yes,
That means this side will be 6 sigma. This side will be 6 sigma. Am I right?
yes,
Yes.
How do I mark 6 sigma? I take center of the process. I take one of the nearest spec. I measure the distance. That distance I am expressing in terms of number of standard deviation. In this condition, the process is considered to have a 6 sigma capability. This is what is known as 6 sigma process.
Yes.
This is what is known as 6 sigma
6
process.
sigma.
In this situation, if you measure CpK, that will be 2. And in this situation, Cp and CpK will be same. If the process is moving to the right or left, CpK will immediately drop. CpK will immediately drop. So CpK differing from Cp is an indication that your process is shifted either to the right side or to the left side. So you have to take some action. If you ignore all those conditions, definitely no, it is not good for the long-term performance. Have I answered your question?
yes, sir.
Okay, now other question. Another participant asked, sir, I have only one specification. I don't have specification on the other side. Yes or no? I want
Yes.
all my food products to have minimum 50 gram weight. If I give more than 50 gram, customer no enjoy it because I'm giving more food for them. Isn't it? But less than 50 gram, it is a trouble. So in this case, only lower spec is applicable, not upper spec. Whenever specification is applicable on one side only, you are supposed to use only CpK, not Cp. What is the thing you should follow?
CpK.
You have to check only CpK and not Cp. Clear all of you? So Cp should not be used when you are working with only one-sided specification. Clear? You got the answer for your question?
Yes, sir.
Yeah. And also please
Why
note
is it like that,
CP.
sir?
Yes.
Why is it only we have to use CPK? Why is it like that?
Because what is the purpose of CP? Purpose of CP, what is the name of CP first of all?
To
Potential,
identify the capability.
potential process capability ratio, isn't it?
Yes, sir.
Yes.
Yes.
It is only telling you the potential, not the reality. Please. What is your potential to score mark in the exam? What do you think?
60% minimum.
Potential itself is 60%. Then the performance will be lower.
Potential is the 100.
Potential 100.
You think that you are scoring 80. You are preparing accordingly. So your potential is 80%. But when you actually write the exam, you will score slightly lower than that. Because your potential itself is 80. You are planning for 80. And so your actual reality will be slightly below 80. So CPK will always be below CP. CPK will always be below CP.
Below CP.
And since CP has a limitation, you must understand. CP only compares your spread of your process against the tolerance. What is the formula for CP? By the way, I did not tell you the formula, but Vivek Kumar sir would have discussed with you. Isn't it?
Tolerance.
What is the formula?
USL minus LSL upon 6 sigma.
USL minus LSL upon 6 sigma. Where is the average here? Average is not there. Can you see that?
Yes.
You are only checking the car and checking the road, and you are telling that you can reach the destination, but you are not checking the driving skill of the driver, isn't it? If a drunken driver sits in your car, what will happen?
It's somewhere.
If a drunken fellow come and sit in your car, will you reach the destination? He will take you to heaven. So X bar required to be included. Since your process is already, see, CP will not check whether your car is going to the right side or going to the left side. Already you are telling that, my process is sensitive only on the left side. But wherever it goes, right or left, CP will, only check the size of the car and size of the road, size of the tolerance given by the customer and spread of the process. So it is better to avoid looking at CP in the case of one-sided tolerance. But if you look at the CP, nothing wrong. Let me tell you, let's say a scenario. You are seeing my screen, right?
Yes.
Okay. So, and see here, your CP is very good, 2. But CPK is 0.8. And your process is one-sided. What is your situation now? You are producing lot of defects. Yes or no?
Yes.
You are definitely producing lot of defect. But your car is too good. Can you understand? You have a very smaller car, but still your people are driving very badly. Yes or no? Your people are driving very badly. So if you actually work on improvement, it will definitely fetch the result. Do you understand? Only the driver is problematic. Car is good. Change the driver immediately. You give the car to a good driver. Same car, will run very smoothly. So that is the message you are getting if you have a healthier CP and a poor CPK. But at the same time, since the process is one-sided, it is better you base your decision straight away on the CPK. But if you want to use the CP, this is how you must use. Hope now it is clear, right?
What's the formula for CPK, sir? CPK.
Formula for CPK, va? Formula for CPK is minimum of CP upper or CP lower. CP upper or CP lower. And CP upper USL minus X bar divided by 3 sigma. And CP lower X bar minus LSL divided by 3 sigma. So I suggest all of you not to worry about all these formulas, right? And there is a way, we will equip you. Don't worry. We will equip you with the methods to derive all this value. If you feed the data in Minitab will do everything and then throw the complete capability report, all the graph, right click, copy, and then present it to your management, right? And these formulas, yes, they are given in your slides also. You can read and maybe we'll take a look little later. It will take more time. I don't want to delay your
Sir,
dinner.
one doubt, sir.
Yeah,
What is the difference? How much is the difference required between the CP and CPK?
no difference is required. Ideal condition, CP and CPK should be equal.
Excuse me, sir.
Ideal condition, CpCpK should be equal. Yes.
Okay.
Sir, I have a doubt. Can I share my screen?
Oh, yes, please. But provided all of you should be comfortable, almost I am done now, and any further delay is from the participants. Those who want to go for your dinner and sleep, feel free to do that. Yeah, yes, one participant is asking. Yes, sir, you have moisture level, right?
Yes, sir.
Okay.
Actually, in food industry, we are supposed to maintain a moisture level. So the customers ask for a moisture level between 3 to 5%.
Oh, 3 to 5%. Lower spec is 3, upper spec is 5.
Yes.
Very
And
good.
these are the recorded values.
Mm.
After taking 10 samples, these were the results obtained.
Very good. Mm.
How we will apply here?
First of all, you have taken 10 samples, all at a time or different time?
No, all at a time, between in an hour.
Oh, within an hour, right?
Yes.
Okay, that means okay, because you have to now decide on your sample size, right? Decide on your sample size. What I suggest is, if you consider everything as a sample collected at the same time, this forms the first group of sample. This forms the first group of sample, right?
Okay.
Same manner, after 1 hour, again take another 10 reading.
Okay.
Again, after 1 hour, take another, because you need to have number of subgroups of data. This is only first group. Make sure you at least have 5-6 groups of sample. And inside every group, how many sample you have?
10 samples.
So the subgroup size is 10. Subgroup size is 10. And number of subgroups, you need to have at least 5 or 6 subgroups. All right?
Okay.
If you do it that way, you can immediately, for every group, you can calculate average.
Okay.
That is called a subgroup average.
Okay,
And for every group, you can calculate the variation also.
Okay.
And what I will do, I will show a simple case now, and equivalent to that, and then you can you will understand. I will use Minitab. I advise you to use Minitab because Excel we have to apply a lot of formula. So let me show you quickly, and then you all can leave the meeting. So I'm sharing my complete screen. I have taken the what you call the Excel file. Yeah, Excel file. Yeah, just a minute. Excel. So let me take some data here. Let me go to. I'll share all of these things in your group and instruction to install Minitab also, and try to practice. You will feel more comfortable. Cutlet diameter, coating thickness is the one I want to find. As here, coating thickness. All of you, can you see coating thickness?
Yes.
Yes.
See here, there are 75 data I have. I'm just showing you. Coating thickness is expected to be in this range, 50 plus or minus 3 microns. All of you, can you see that?
Yes, sir.
The upper spec is 53, lower spec is 47. Like our participant told, he took 10 readings at a time. I took 3 reading at a time. Can you see that?
Yes.
Yes.
3 reading is my first group. My sample size is 3 only, not even 10. But still it can give a meaningful conclusion. First 3, next 3, likewise, I have 25 subgroup. Can you see that, all of you?
Yes.
if I have 25, then only I can talk about duration of data collection. Yes or no? If I
Sir, how
collect the
many
data,
subgroups are required minimum?
come again.
How many minimum subgroups are required?
See, that's what I told you. Remember, you have to define the duration of data collection in a logical manner. If there is a logic, you go with it. There is no strict rule. In my opinion, in your company, at least you throughout the day you maintain every 1 hour you collect data. It will be a good study, isn't it? Because
Yes, sir.
if you have taken a sample at a very very in the afternoon time, and that is not actually advisable. That time probably the humidity maybe will be affected by the temperature. So you should actually go for a considerable wider period of time. So now here 25 subgroup, each 3. I copy all of them. All the calculation manually I have done here, but I will explain to you slightly at a later time. Right? And those of you who are green belt, maybe you can check whether you can upgrade to the black belt, because only when the basics are built, I can talk about the theory in detail. Otherwise, talking too much theory might lead to confusion also. I don't want that to happen. So I'm coming here to the mini tab now. You should be able to see the mini tab now. And now I open the spreadsheet. I want some spreadsheet, yeah, here. And now I will place all that copy data here. A mini tab can simplify your task. Oh, sorry, I made a mistake. Control Z. I should paste it here only. You remember I told you this is thickness. Thickness. Now I want to do the perform the capability study. I need CpCpK. So go to stat, go to quality tools, go to capability analysis, go to the normal. Click. Now this window is coming. Now it is asking you, where is your data? Where is my data? Data is available in column 5. What is your subgroup size?
75.
What is the subgroup size in my example?
75, sir.
3.
75
Simple,
is
sir.
not subgroup
3.
size, 3. I had 25
3.
subgroup and each subgroup 3 samples. So subgroup size is 3. Now you have to declare lower spec. What is your lower spec? 47.
47.
What is your upper spec? 53.
3.
Now you give
52.
okay, your job is done. Can you see a capability report? All of you? Are you able to see the report or not?
Yes, sir.
Yeah. Tell me what is the CP?
2.46.
2.46.
2.46. What is your CPK? How much?
2.37.
27.
Are you happy with the value?
Yes, sir. Almost near.
You are extremely happy.
Almost equal.
Because what is required is 1.6 only, AAG guideline, but you have much more higher than that. Look at the expected rejection. Currently, according to the data, 0 rejection, nothing rejected on the lower spec, nothing rejected on the upper spec. It doesn't mean that, no, the situation will remain same. In the long run, 293 parts might get rejected on the left side and 100 parts might get rejected in the right side. But this is only in the long run. If you want to talk about the long run, you should know what is PP and PPK, which I will be teaching you a little later. All of you understand? Very simple, right? What did
Yes, sir.
what I did with Minitab? Very simple task. Very simple task. So see, till the time you become comfortable with the terminology and comfortable with the whatever tools we are using, you might it might look hard, but actually it's very simple. What is that I did? I went to stat. After that, quality tools. After that, come on, you can tell me stat,
Quality
quality
tools,
tools, capability
then
analysis.
capability analysis and normal.
That's all. Now you know how to feed the data. You can even type the data or copy paste and declare all of this. And then, and then your result is, see, it is coming, the result is coming out in a much presentable manner, isn't it? Why do you want to struggle?
Yes.
For the sake of learning, use all the software. Nobody is going to question you. This is only a trial version. You take the trial version 1 month and then use it. Okay, I think you all gained some good insight about both the define and measure phase. Is my understanding correct?
Yes, sir.
Yes.
Very good. So we'll be meeting next week for the analyze and then the improve and see. If you define properly, measure properly, analyze properly, improve and control is nothing. People can easily talk about the solution, implement the solution. It is only a teamwork and cooperating each other. But all these things, the first 3 phases are crucial. That is why we are spending more time. Okay, thank you very much, all of you.
Will you be
And
sharing will you be sharing the manual for how to use the MinTab?
yes, I will be posting detailed instructions in the group. Please acknowledge and then immediately act on it. I'll share the Excel file. You can also practice the same way I explained. I will also share the Minitab installation. And Thursday you have an opportunity to attend some extra class. And whoever can attend, please attend, and that will not be recorded. It is only discussion same thing. So whoever can come, please come. We will
On the same
discuss and then
thing.
clarify your doubt. Okay, I've
Sir,
taken
today's
more
and
time.
yesterday's class will you be uploading today? Today's and yesterday's recordings.
Tomorrow. See, Sunday holiday, you give our people some rest.
Yeah.
Monday they will do it. Yeah.
Okay.
Saturday and Sunday, and then Monday, both together, they will be uploaded tomorrow.
Thank you.
All right.
Thank you, sir.
Thank you,
Thank you, sir.
all of you. Hope
Thank
you
you, sir.
all,
Thank you.
I think you all participated well. We'll be meeting next week. Bye-bye.
Okay, sir.
Thank you,
Right.
sir.
Bye.
Bye. Thank you.